So those who have not subscribed our channel, please subscribe this and like the session if you haven't liked it, and press the bell icon so that you get the notification whenever the video is live. Okay, so good evening everyone. Again, those who have joined late, good evening. So let's start the session. This is Maha Marathon series, and today is I'm going to start the network theory. Okay, but before starting, let me tell you guys, there is one mega workshop for GATE 2024 students, and this workshop is taken with you can join with Abhinav Negi sir, and you can take the advantage of the experience of Abhinav Negi, and it will be on 15th of January, so you can recommend to your juniors and your friends. Okay, so there is one more thing, that is 90% scholarship program is also there, so you can register yourself to avail this offer, and whatever the exam is, it will be on 8th of January, so you can register it. The link is given in the description. Okay, so let's start the session, guys. Let's start the session. So I'm very excited because first time I'm taking marathon session. It's been like 10 to 12 years and I haven't taken any marathon series. So first time I'm going to take marathon series. I hope you like it and you love it. Okay, so let's start. So first thing is, in network theory, the first chapter, cover it and you can cover it easily. Is it clear? I think the video has stopped. Okay, so there was a glitch, there was an internet glitch, and I hope you don't mind. So let's start the session, guys. So the first topic in the network theory is the Ohm's law. Everybody is aware of Ohm's law. V is equal to IR. And we know that in Ohm's law, Ohm's law is V is equal to IR. Now this R is rho L by A. It is independent of voltage and current. Now sometimes we need to calculate equivalent resistance. There are some type of circuit which are provided to you, and we need to calculate the equivalent resistance. Whenever two resistances are in series, you just directly add them, R1 plus R2. Whenever two resistances are in parallel, you take R1 R2 divided by R1 plus R2. Simple, everyone know that. But now this is important. This is an infinite ladder. It is up to infinity. How to solve such type of questions? There is an infinite ladder. Now how to solve these type of questions? To solve these type of questions, what I need to do is, if you look at this block is repeating, this resistance and this resistance, but the values are not repeating, only the shape is repeating. You can see that 2, 1, 1 half, 1 by 4, 1 by 4, 1 by 8. So you can see that this block is repeating again and again. So you can assume that the equivalent resistance is X. Okay, you can assume that the equivalent resistance is X. And if you look at this block, this is one block, this is second block repeating. Let's say if the blocks are repeating, let's say the blocks were repeating, let's say the question is like this. If I take the question like this, then it will be more easier. So first I am telling you about the equivalent resistance, how to calculate the equivalent resistance. Let's say this is 2, 4, 2, 4, 2, 4, and this is up to infinity. If the question were like this, then it will be more easier because the blocks are repeating. Now you can see that this is one block, and this is second block, and it is repeating. Everything is repeating. Okay, so what you can do is, you can assume that the equivalent resistance is X. Now if you remove one block, after removing one block, and if you look at this entire circuit up to infinity, the equivalent will also remain X. The equivalent will also be X. If you remove one block, and after removing one block, if you look at this entire chain, entire ladder, then also the equivalent will be X. So what you can do is, you can replace this entire ladder just by removing one block. Okay, don't look at the first block, just look at this ladder. So if the equivalent is X, if you remove one ladder, with its equivalent resistance X, so the net, and you can replace X here. Okay, and the equivalent will also be X. Now you can calculate the positive value of X. It's easy peasy. Okay, you can solve it. There is no problem, I suppose. Is it fine, guys? From this point onward, you can easily solve. What you can do is, you can take parallel of these two resistance, that is 4x divided by 4 plus x plus this 2 ohm, and the resultant you will get as x. Okay, so I think it's easy to calculate the value of x. But the problem is, in this question, if you look at carefully, in this question the block is not repeating. The block is not repeating. Now tell me how to calculate the equivalent resistance in this case. Can you tell me how to calculate the equivalent resistance in this case? This is an infinite ladder, and this block is not repeating 2, 1, 1, half, half, 1 by 4. Every resistance is getting half. If you look at this 2 ohm, this is 1, this is 1 by 2, this is again half, and this will become 1 by 4. So every resistance is getting half. Now how to solve this problem, guys? How to solve this problem? Tell me, is there any idea? Is there any idea for this type of question? Let's say this is up to infinite. Now how to solve it? Okay, let me tell you. Let's first erase everything and let's come to the original circuit. Okay, this is the original circuit. What I can do is I can assume that the equivalent is x. Okay, now if every resistance is multiplied by half, let's say, in this ladder is up to infinite. This ladder is up to infinite. Now in this ladder, if I multiply every resistance with half, obviously the equivalent resistance will also become half. So you can say that if I multiply this with half, it will become 1. It will become 1 by 2. 1 by 2. Now look at this resistance, it will become half and it will become 1 by 4. Fine, it will become 1 by 4. Now it will become 1 by 4 and 1 by 8. I hope you understood. So if I multiply every resistance with half, the resultant will become x by 2. I hope you understood. It. It's up to infinite. What I did is I have assumed that the equivalent resistance of this infinite ladder is x, and then I multiplied every resistance with half. So the equivalent will also become x by 2. Is it fine? Now what I can do is, now you can see that if you look at this ladder from this point onward, okay, if you look at this ladder from this point onward, 1 half, half 1 by 4, and the same thing is x by 2. I have represented here 1 by 2, 1 by 2, 1 by 4, 1 by 4, 1 by 8. Okay, so what you can do is you can replace this entire ladder from this point onward with x by 2, and the resultant is x. Is it fine? So what I can do is the first block is same, 2 ohm, and then I have represented here 1 ohm. The equivalent value is x, but this ladder from this point onward, this ladder can be represented with x by 2, because you can see that 1 by 2, 1 by 2, 1 by 4, 1 by 2, 1 by 2, 1 by 4. This ladder is x by 2. So what you can do is you can replace here with x by 2. Tell me guys, have you understood it? Is it fine? In the previous case, what we have done is we have not, in the previous case, the blocks were repeating. So what you can do is you can remove that one block, remove the first block, and replace this entire ladder with x only. Because if you remove one block, then also the equivalent resistance of the entire ladder will remain as x. But in this question, since the block is not repeating, block is getting halved. So what you can do is assume that the equivalent resistance is x. You just multiply every resistance with 1 by 2. So obviously this x will become x by 2. If you multiply every resistance with half, this will be the new ladder, and the equivalent resistance will be half, x by 2. Now what you can do is, if you look at this ladder carefully, this x by 2 came here. Okay, this is x by 2. So you can replace this entire ladder with x by 2. I hope you understood it. Okay, and now you can calculate the value of x. Is it fine, guys? Tell me, is it fine? Is my audio clear or not? Let me now please check it. Kishan Kumar, I think it's clear now. Is it fine now? Is audio clear? Tell me guys. I think audio is fine now. Okay, so I told you how to solve this question. I think it's easy peasy. Now you can understand this, how to understand this question and how to solve it. Okay, let's move to the next case. So this is for infinite ladder. I told you sometime the question came in the form of infinite ladder, and you can solve it directly like this. Let's come to the other type of equivalent resistance. In exam, this type of circuit came. Now the problem is, in this type of circuit, we don't know which resistance is in parallel and which is in series. Okay, in the previous question, you can calculate the value of X. It's easy peasy, okay? Now let's come to the next question. In this question, there are some situation in which this type of question can be asked. Now, in this type of question, you can't say which one is in parallel and which one is in series. Now, how to solve this type of question? Now, how to solve this type of question? Let me tell you how to approach this type of question. What you can do is, you can name these junction, these node point or junction point. First of all, if you don't know which one is in parallel and which one is series, then what you can do is, first step is to name these junction points. You just name these junction point. How to name it? A is this, B is this, so better you name it C. Okay, if this point is C, this will also be C because there is a direct connection here. Okay, if this point is C, this point will also be C. If this point is C, this point will also be C. Is it fine? This point will also be C. Now we call it this point as D. If this point is D, this point will also be D because there is a direct connection. And if this point is D, this point will also be D because there is a direct connection. I mean, this is not a common point. Let me do it like this. This is above it. Okay. So this is not. I mean, this point is not. There is no joint here. Okay. So be careful, guys. If this point is D, this point will also be D. Okay. Now what you can do is, once you get the naming of this node, now you can simplify this circuit. Now we can simplify this circuit. How to simplify it? It's very simple. Start with A. Okay. So you start from A and you write it like this. From A to C, you have 4 ohm. From A to C, you have 4 ohm. Fine. From A to C, you have 4 ohm. Now, this resistance I have covered. Now, I need to write from C to D. Okay. From C to D. How many resistance are there from C to D? C to D is 6 ohm. Okay. I have represented 6 ohm here. C to D. This C to D is covered. Now, there is one more C to D, 6 ohm. So, I need to show it in parallel. 6 to D. There is one more resistance 6 to D. 6 to D. There is, C to D is 6 ohm. Again, there is one more resistance C to D, 6 ohm. So, I have to represent this in parallel. C to D. That is again 6 ohm. And this resistance I have shown it. Now, this resistance again C to D. One point is C, one point is D. So, you can say that I have to show one more resistance C to D. Okay, C to D, 6 ohm. This resistance I have covered, C to D. Now, there is one more C to D, one more C to D, and one more. There are 3 resistances. So, you have to show 3 more resistances C to D. Is it fine, guys? C to D, this. Now, C to D, this, and there is one more C to D. Every resistance is 6 ohm. Okay. I have shown these resistances. Now, from D to B, 4 ohm. From D to B, you have 4 ohm. Is it fine, guys? D to B, you have 4 ohm, and you can solve it easily. Okay. So, this way, this question will become simpler. Okay. You can simply solve this question. Now, this 6, 6, 6, 6, 6, 6, these are in parallel. 1, 2, 3, 4, 5, 6, 7. So, the equivalent of these resistances will be 6 by 7. So, now what you can do is, you can further simplify it. This is 4 ohm. Okay. And this resistance is 6 by 7 ohm. And here you have 4 ohm. Is it fine, guys? So, this point is A and this point is B. Now, you can calculate the equivalent resistance. That will be 8 plus 6 by 7. Okay. I hope you understood it, how to solve this type of question. So, remember, there are some situations in which you are not able to look at the resistance. I mean, which resistance is in parallel, which is in series. So, what you can do is, you can simplify the circuit. You can use the path method to simplify it. We call it path method. I mean, I call it path method. You name it your, I mean, whatever name you want to name it, you just do it. But the simple part is, the easy part is, what you need to do is, first you name the node point. First you name the node point. After naming the node point, you make it simpler. You make this circuit simpler. How to make it simple? Use the path. From A to C, you have shown like this, and then from C to D, C to D, C to D, every resistance is from C to D. Okay, so you can show it. Now there are some situations in which, let's say there is one resistance which is starting from the same point and end at the same point. Let's say there is a resistance. Let me connect a resistance here, and let's say there is some resistance, and resistance is connected like this. There is some resistance which is connected like this. Now if you look at this resistance, this point is D and this D and D. What you can do is you can leave this resistance. No need to cover this resistance, no need to take this resistance, okay? Because it has the same point on both the terminals. So the voltage difference across its terminal will be 0 and you can leave it. You don't consider this resistance in equivalent resistance. I hope you understood it, okay? So this type of question may came in exam, okay, on equivalent resistance topic. So this was infinite ladder case, and this is again, you can say path method, okay? Let's come to the next. That is star delta conversion. Okay, star delta conversion. Now, what is star delta conversion? Everyone know that. Everyone know. If let's say this is given in star and I need to convert in delta, it's very simple. Tell me guys, how to convert it from star to delta? If you want to convert from star to delta, how to convert, guys? Tell me. If you look at carefully this circuit, let's say this RA, RB, RC are provided to you. It is given to you. Now I want to convert it into delta. I want to know this RAB. Now RAB, look at this RAB. This resistance is connected between A point and B point. Okay. This resistance is connected between A point and B point. If you look at this carefully, between A and B, you have RA and RB. So what you can write is RAB will be equal to RA plus RB plus RA-RB divided by RC. This way you can calculate RAB. Similarly, you can calculate RBC, because RBC is between B and C. Between B and C, there is RBC resistance. So what you can do is between RB and RC, between B and C, you have RB and RC. So RBC will be equal to, you can easily write as RB plus RC, RB plus RC plus RB RC divided by RA. Is it fine? Similarly, you can calculate RCA. Okay. So this is from star to delta. Let's say some star connection is given and you want to convert it in delta, then you can easily convert it like this. Now, let's say delta is provided to you and you want to convert this in star. Now, how to convert delta into star? It's again simple. Let's say these resistances are provided to you. If these resistances are provided to you, then how to convert in star? We want to calculate this RA value, RA. Now, how to calculate RA? RA is connected to point A. Now, if you look carefully at point A, there are two resistances which are connected, RAB and RCA. So, what you can do is you can multiply them, RAB into RCA, divide by the total sum of the resistances. That is equal to RAB plus RBC plus RCA. Is it fine, guys? This way you can convert from delta to star. Let's say you want to convert RB. What is RB? RB is connected to point B. And if you look carefully at point B, there are two resistances. So what you can do is RB will be equal to product of these two resistances divided by the sum. Okay. So this way you can convert from star to delta or delta to star. Now I think it's easy. The same concept is applicable on inductor also. Let's say there are some inductances. Okay. There are some inductances. Inductances are given like this. Okay. LA and LB and LC. And there is no mutual coupling. There is no magnetic coupling. Now what you can do is you can convert this star into delta. You can convert this star into delta. The same rule will be applicable. Okay. The rule which is applicable on resistance, the same rule will be applicable on inductance also. If there is no coupling, remember this point, what I'm saying. If there is no magnetic coupling, if there is a coupling, then you can't do it. Okay. Then it will change. The formula will change. You can't apply this formula if there is a magnetic coupling. Let's say this inductor and this inductor and this inductor are coupled via some mutual inductance. Then you can't convert it like this. The same formula will not be applicable, but if there is no magnetic coupling, you can apply the same formula. The problem is with capacitance. In capacitance, you can't apply this formula, this resistance case formula. Okay. In capacitance, whenever the capacitance is given in star, and if you want to convert that capacitance into delta, you can't apply the same formula. Okay, let me tell you. Let's say I have the capacitances like this. This is CA, CB and CC. This point is A, this point is B, and this point is C. We call it CA, CB and CC. I want to convert this capacitance into star. Coupled wire में कैसे होगा sir? Coupled wire में मैं बताऊंगा आपको. Don't now, maybe in the coupled circuit I'll teach you. But right now I'm not teaching the coupled part, I'm teaching you the basic part. That's why I'm avoiding the coupling. Okay. So I told you whether it is resistance or inductance, you can apply the same formula. In place of resistance, you can replace inductance. Okay. But the problem with the capacitance, in case of capacitance, you can't apply the same formula. Let's say the capacitances are given in the question like CA, CB and CC. And I want to convert this in delta. I want to convert these capacitances in delta. Now, how to convert these capacitances into delta? Tell me guys. A point, this is B point, this is C point. This is CAB. How to convert it? This is CBC. How to find this? CA. Okay. Now, what you can do is there are two ways. Let's say you want to find CAB. So what you can do is you can invert these values. If you invert these capacitance values, it will act like a resistance. Okay. So let me invert these values. 1 upon CA, 1 upon CB. Now this is a trick, just remember it. 1 upon CC. Whenever you have capacitances in any circuit, and if you want to calculate the equivalent capacitance, let's say between A and B, you want to calculate the equivalent capacitance, or between B and C and A, what you can do is you can invert the values. 1 upon CA, 1 upon CB and 1 upon CC. Now it will act like a resistance, and you can apply the same resistance formula, which I have already written. So you can write that same formula. Okay. So let's try that. Let's try to apply that. Okay. So these are the resistances now. So first of all, I want to calculate the resistance between A and B. So what is the resistance between A and B? Tell me guys, what is the resistance between A and B? The resistance between A and B will be 1 upon CA plus 1 upon CB plus 1 upon B, because if resistances in star are given, you can convert the resistance in delta. So the resistance in delta came out to be 1 by this RA plus RB plus RA/RB divided by RC. The same I did, 1 by CA plus 1 by CB plus 1 by CA/CB divided by CC. Now this is the resistance. This is the resistance value between A and B. But we want the capacitance value. So what you can do is you can invert it. Okay. So this is one way to solve for the capacitance. CAB will be equal to, you just invert this value. So what you will get is 1 by CA plus 1 by CB plus CC divided by CACB. Okay, this is the equivalent resistance between A and B, but we want capacitance. So you further invert it. You further invert it and you will get the CAB. So if you invert it, then CAB will be equal to, what is the LCM? LCM is CACB. So CACB divide by CA plus CB plus CC. Okay, this will be my CAB. We have calculated CAB. Now, if you look at this formula carefully, you can say that the formula which was from delta to star, in case of resistance, the formula which was applicable for converting delta to star, the same formula is applicable in capacitance from star to delta. From delta to star, if you want to convert the resistance from delta to star, what was the formula? The formula was this: RAB RCA divided by sum of these resistances, and you can calculate RA. Now if you want to calculate the capacitance equivalent CAB, and if this 1 by CA, 1 by CB and 1 by CC are provided, what you can do is you can apply the same delta to star formula of resistance case in capacitance, but in capacitance the same formula will be applicable from star to delta. If you want to convert from star to delta, you can apply the same formula, the delta to star in resistance. It means the formula had changed. Is it fine? So now the CAB will be equal to product of these capacitances, that is CA CB divided by CA plus CB plus CC. You can directly use it. Okay. So this way you can remember the formula also. Okay. In star to delta, whenever you want to convert the capacitances from star to delta, what you can do is you can apply the same formula as resistance, but the formula had changed. The formula from delta to star in case of resistance is applicable from star to delta in capacitance. Is it fine, guys? I hope you understood it. Tell me, guys, have you understood it? Yes. The formula is changed. The formula is changed. Or what you can do is, you don't remember the formula. You remember this resistance formula only. Okay. Only this resistance formula is required. What you can do is, you can convert this in resistance like this, 1 upon CA, 1 upon CB, 1 upon CC. Now it will act like a resistance and you can apply the same resistance formula. So calculate the equivalent resistance and then invert it. And then further invert it to calculate the capacitance value. Okay. So this way also you can do it. I think it is easy peasy. Now this concept is universal. Not in star and delta. I mean, anywhere you can apply. Let's say there is a combination of capacitances. There is a ladder of capacitances, let's say. Okay, in the ladder of capacitances, you want to calculate the equivalent capacitance. So what you can do is, you can replace every capacitance in inverted form, you can replace it. Now it will act like a resistance. So calculate the equivalent resistance. Whatever the equivalent resistance is, you further invert it, you will get the equivalent capacitance. Tell me, guys, have you understood it? And tell me, guys, is it clear? Sir, delta to star in capacitance, right one. Okay, let me tell you. So from star to delta, this formula is applicable. Now let's say this is given, CAB, CBC and CCA given. Let's say these are provided to you and I want to convert this, I want to calculate this CA. What you can do is, now you can apply the same formula which is for in case of resistance, but in case of resistance, star to delta is applicable here from delta to star. If you are converting the capacitance from delta to star, then you have to apply the same resistance formula, but the resistance formula would be from star to delta case. Okay. Let me try this. Let me erase this and okay. Let me erase this. Okay. Let me erase this part so that I can apply that formula from delta to star. There are two ways. There are two ways to convert from delta to star. And what are those ways, guys? Let me tell you. What are those ways? Let's say you want to convert CA, CB, CC, and these are provided. What you can do is you can write them 1 upon this, and 1 upon this. You just invert them. Now they will act like a resistance. Now the same resistance formula will be applicable. Since you have converted them in resistances, now you can apply the same resistance formula. Okay. You don't need to convert in capacitance or something else. Now you just apply the direct resistance formula because you have converted them in resistances. If you have converted them in resistances, now this RA, the resistance which is connected to A, RA will be equal to, tell me guys, it will be equal to this into this. That is 1 by CAB into 1 by CCA divided by the total sum. The total sum is 1 by CAB plus 1 by CCA plus 1 by CBC. Okay, you can do it like this. Now if you simplify it, what you will get is, you will get in the numerator you have 1 upon CAB into CCA. This is in the numerator, and in the denominator if you take the LCM, it will be CAB, CBC, CCA divided by CCA, CBC plus what is this, CBC, CAB, CBC plus there is one more term, that is CAB, CCA. Okay, this way you can write. Now it will be cancelled. CAB, CCA, these two terms will be cancelled. Now this is the equivalent resistance. What you can do is you can invert it. To get the capacitance value. So CA came out to be, tell me what is CA? CA came out to be this divided by this CBC. Now it will be CCA plus CAB plus CCA, CAB divided by CBC. Okay, this will be the capacitance CA. So you can see that, now you can see that the formula which was applicable in case of resistance from star to delta, this formula, the same formula is applicable in capacitance, but it is from delta to star. If you want to convert from delta to star, then the same formula will be applicable. You can see it from here. Okay, so the same formula is applicable. What you can do is, you can directly apply the same formula, RB plus RC. So now, since you want to calculate CA is connected at this point. So what you can do is CAB plus CCA plus product of these two divided by the third one. Okay, this way you can calculate this capacitance. So you can say that the resistance formulas which were applicable in case of resistances, the same formulas are also applicable for capacitance, but the formula which was from star to delta in case of resistance, the same formula is applicable in case of capacitance from delta to star. Is it fine, guys? I hope it is clear. Tell me everyone, is it clear? Just give me 1 minute so that I can adjust this mic, because this mic is, wait a minute guys, let me adjust this mic. Actually it is creating problem. Am I audible? Tell me guys, am I audible? Tell me. Okay, that's great. But let me tell you one more point. The trick I told you that you just replace C as 1 by C and then make it as a resistance, then calculate the equivalent resistance and then further invert it. This trick is very helpful, not even in star delta conversion, or let's say there is some question. Let's take some question. Let's say this is the question. Let's say I have this question and there is a voltage source provided here. This voltage is 20 volt. This is 1 by 4 farad, 1 by 8 farad, 1 by 16 farad and 1 by 8 farad. Let's say this is the question and I want to calculate this voltage. What is this voltage? VC. Find VC. Now how to calculate this VC? One way is using the charge concept, okay, that you have studied in 12th class. But there is one more way, and that way is, what you can do is you can convert these capacitances into resistances, into equivalent resistances. So what you can do is you can invert the values. Now this capacitance will act like a resistance, okay. This is a trick you can apply anywhere. So let me apply this trick. This is my 20 volt. This is my 20 volt. Now what you can do is you can invert the value. This is 4, this is 16, this is 8, and this will be 8. Now you can invert the values. They will act like a resistance. Now what you can do is you can calculate this current. This current multiply with this 8, this will be the voltage across this resistance, and the same voltage will be across the capacitance. Voltage you can't invert, okay? Don't invert the voltage itself, okay? So you can apply the same trick in calculation of the voltage across the capacitances. What you can do is you can invert the values first. So 4, 8, 16, 8. Now if you take the sum of these two capacitances, I mean now that they will act like a resistance. So it will behave like this. This is 8 farad, this is 8 ohm. Now this 16 and 8, this 16 and 8 will be in, tell me, this 16 and 8 will be in series. So their equivalent capacitance will be, tell me guys, what is the equivalent capacitance? Equivalent resistance. 16 plus 8, that is 24, and here you have 4 resistance and here you have 20 volt. Is it fine? Now what you can do is you can calculate their equivalent resistance value. You calculate their equivalent resistance value. 8 and 24 are in parallel, and since they are resistances, so you can calculate their equivalent as 8 into 24 divided by the total sum. Total sum is 32. Okay, 6. So their equivalent is 6. 6 plus 4 is 10. It means the equivalent resistance is 10 ohm. So the resultant current will be 2 ampere. Is it fine, guys? The resultant current will be 2 ampere. It means the current here will be 2 ampere. Okay? I mean, don't show the current here. Okay? Don't show the current in the original diagram. Okay? You can say that the current will be 2 ampere. Now, what about the voltage here? Can you calculate the voltage across this capacitance? Obviously, 2 into 4. This 4 will act like a resistance. So 2 into 4 is 8 volt. So you can replace that, you can say that this voltage will be 8 volt. In the original diagram, in the original circuit, this voltage will also be 8 volt. So it's a trick. It's a trick. Using this trick, if you invert the resistance capacitance value, it will act like a resistance. If these are the resistances, you can calculate the current here. You can calculate the current. Using that current, you can calculate the voltage across this resistance. The same voltage will be here in case of capacitance. So you can apply this trick. Have you understood? Say yes or no. Tell me, guys. I hope everyone has understood this topic. Now, similarly, you can calculate this capacitance, this voltage. How to calculate this voltage? We know that this is 2 ampere. What you can do is you can calculate this current first. This side current. What is the current value in this side? So you can apply the current division rule. If you apply the current division rule, you will get this voltage. You will get this current. Multiply by 8, you will get this voltage, and the same voltage will be available here. Is it fine? So it's a trick. You can apply this trick anywhere. It's similar to this case. Now, whenever the capacitances are given in star or delta, you can invert them and you can convert them in resistances, and then you can apply the same resistance formula on the capacitance. Okay, you can calculate the equivalent resistance between these 2 points, but we want capacitance, so further invert the resistance value. Further invert the resistance value to get the capacitance value. Is it fine? So I think this is easy. Let's proceed further. So this star delta conversion, where this star delta conversion is used, there are some situations where we are going to use the star delta conversion in the calculation of equivalent resistance. We use star delta conversion. Now, what are those situations? Let's say there is a bridge and the bridge is not balanced. Let's say this is the bridge, guys. Let's say we have a bridge like this, and we want to calculate the equivalent resistance. Let's say we have bridge 2, or maybe not 2. Let's make it 6, 9, 6, and there is one more 6. Okay, and this point is A, let's say, and this point is B. Now, if you want to calculate the equivalent resistance between RAB, how to calculate the equivalent resistance? Tell me, guys. Obviously, this is not a balanced bridge because this upon this is not equal to this upon this. Because 6 upon 6 is 1 and 6 upon 3 is not 1. 6 upon 9 is not 1. So this is not a balanced bridge. Okay, this is not a balanced bridge. If this is not a balanced bridge, now you can apply the delta. Now you can see that this side is delta, this side is also delta. So you can convert one delta into star. It's easy to convert this delta because it has symmetric value 666. Now what you can do is you can convert here the delta into star, and then you can easily solve. Okay, so if you convert this delta into star, can you calculate can you tell me the value of this star? What will be the star resistance? Can you tell me what will be this star value? This 6 into 6 divided by 6 plus 6 plus 6. Tell me, guys. So it will be 2 ohm. 6 into 6. This resistance, this orange color resistance, this 6 into 6 divided by 6 plus 6 plus 6. Is it fine? So it will be 2 ohm. So what you can do is you can replace this delta. You can replace this delta with the 2 ohm resistance. Okay. Now this resistance will be 2 ohm. 2. And you can solve the circuit. You can calculate the equivalent resistance. Okay. So it's very simple. It's very easy. Okay. But there are some students who are very confused with the bridge. Let me tell you, guys, there is one interesting point where you can make mistake. Let me tell you. Let's say you have a circuit like this. Let's say you have a circuit like this. Okay. Let's say I have the circuit like this, and this is 2, 4, 6, 8, 16. Okay, and I connect one more resistance here, and let's say this is the circuit. Let's design a circuit like this. I call it A, and this point is B. Now can you tell me, let's say this is 6 ohm, this is 6 ohm, this is also 6 ohm, and this is also 6 ohm. Now can you tell me whether this bridge is a balanced bridge? I mean, can I remove this 6 ohm because this is balanced? 2 by 4 equal to 8 by 16. 2 by 4 equal to 8 by 16. Since 2 by 4 equal to 8 by 16, can I remove this? Tell me, guys. Can I remove this? Say yes or no. Can I remove this? Tell me. Can I remove this 6 ohm? Because if you look at this bridge now, this looks a balanced bridge. 2, 4, 8, 16. So 2 by 4 equal to 8 by 16. So you can remove this middle branch now. Can you do it like this? Can you do it like this? Tell me guys, can you remove this 6? Answer is no, you can't remove it. Okay, you can't remove it. Why? Because it will be a balanced bridge if whatever current which goes on this side, the same current will go on this side. Or you can say this point voltage and this point voltage same, then only you can remove this middle branch. But in this circuit, yes, it looks a balanced bridge, but the problem is whatever current goes here, it's not necessary that the entire current will go here. It might be possible that some current will go in this lower branch. So it's not necessary that the same current will go here. Is it fine? So you can't replace this 6 ohm. So when to replace this, when to remove this 6 ohm? When to remove this 6 ohm? Whenever there is a balanced bridge. But this is not a balanced bridge. You can't say that this is a balanced bridge because the problem is there is a connection here. There is a connection. There is one more connection here. If there is a connection like this, if there is a connection like this, if this point is connected or this point is connected, and if there is a current division at this point, let's say some current is some current is going on some separate path. The entire current is not flowing in this direction. There is a division here. You can see that there is a division here. So you can't apply the balance bridge concept. This 6 will not be removed. Just remember this point. I hope it is clear to everyone. Is it fine guys? Tell me. सर चार्ज भी सेम होगा क्या हर ब्रांच में, ओरिजिनल सर्किट और रेजिस्टेंस वाले केस में, कैपेसिटेंस वाले केस में? ओके, इन दिस क्वेश्चन ना, यू आर आस्किंग इन दिस क्वेश्चन लेट्स से यू वांट टू कैलकुलेट द चार्ज वैल्यू. सो व्हाट यू कैन डू इज first you calculate the capacitance value, first you calculate the voltage value, no? First you calculate this voltage value. Now Q is equal to CB, we know that. So once you get this voltage value, multiply it with C, you can calculate the charge. You can calculate the charge on the plate. Okay, so it's easy, Sahil Soni. You can calculate the charge value also. Okay, so let's come back to the original question. Let's come back to the original case. So I told you in balanced bridge or Wheatstone bridge, don't be confused. There are some students who think that you can remove it. Okay, you can remove this 6 ohm, but actually it is not. Okay, you can't remove it. Okay, let me tell you one more case. Let me tell you one more case, guys, where you get confused. Let's say there is a circuit like this. There is a circuit like this. Let's say we have a circuit like this. 4824. Okay, and there is a voltage source like 20 volt, let's say, and there is a resistance of 6 ohm in series with a voltage source 10 volt. Now you can see that this is a balanced bridge. Now 4 by 8 equal to 2 by 4. Can you remove this middle branch? Say yes or no. Can you remove this middle branch? Tell me guys, can you remove this middle branch? This bridge look balanced, no? 4 by 8 equal to 2 by 4. 4 by 8 is 1 by 2 and 2 by 4 is again 1 by 2. So can you remove this middle branch? Tell me, say yes or no. Tell me, how many of you think that you can remove it? Tell me guys, can you remove this middle branch? Answer is no. You can't remove this middle branch. This is not a Wheatstone bridge. This is not a Wheatstone bridge. Wheatstone bridge will be there. You can apply the concept of Wheatstone bridge only if the middle branch does not have any sources. Let's say only 6 ohm is there. Then you can remove this 6 ohm, but you have a voltage source here. Now because of this voltage source, you can't say that this point and this point have same potential. There is a voltage difference. Okay. So this point and this point will not have same potential and you can't remove this middle branch. This is not a balanced bridge. This is not a Wheatstone bridge. Please be careful. You can't remove this middle branch. Whenever you have a source in the middle branch, whenever you source in the bridging branch, in the bridge branch, whenever you have a source, don't remove the bridge branch. Remember this point. You can't remove it. Is it fine, guys? I hope you understood this. How to handle this bridge case. Let me tell you one more example. Let's take one more example. Okay, I need some free space. Okay, now I can tell you everything here. So let's say I have an example like this. Let's say there is a circuit like this. Let me take a circuit like this. I want to ask you one point. Let's say this point is A and this point is B. Okay, 6, 6, 6, 6, 6, 6, 6. How many of you think that this is a balanced bridge and we can remove this 6 ohm? Can you remove this 6 ohm? Tell me, say yes or no. Can you remove this 6 ohm? Tell me guys, say yes or no. Can you remove this 6 ohm? Because this 6 by 6 and this also 6 by 6, so you can remove it. Tell me, can you remove it? Can you remove it? No, you can't remove it. Why can't you remove it? Tell me, whatever current which will going on in this branch, the same current will not flow here. The problem is, it will be divided into 2 paths or maybe 3 paths. It can divide here, it can divide here, or it can go, some part of the current can go on this side. So this entire current is not flowing in the lower branch. Is it fine? That's the main problem. That's why you can't say that you can remove this resistance. No sir, you can't remove it. Okay. So there is a current division here. So be careful. This type of situation may confuse you. Okay. And be careful about this type of situation also. Okay. I hope you understood it. And be careful about the capacitance case. Whenever there is a capacitance, let's say this is the circuit and you want to calculate the charge of this charge on the plate of this capacitance. What you can do is you can invert the value of the capacitance, make it resistance, calculate the voltage here. By replacing it with resistance, you can calculate the voltage here. Once you get the voltage, the same voltage will be available here. Multiply this voltage with the capacitance value, you will get the charge. Okay. So I think it's easy peasy. Can I proceed guys? Can I proceed? Now let's come to the new topic, and that new topic is sources. Okay. Let's discuss the sources. Everyone know about the sources. There are voltage sources and current sources. Okay. In voltage sources, you have dependent voltage sources, independent, and similarly in current sources, dependent and independent. Everyone know this. Everyone know this. Okay. Now what I want to tell you is there are some confusion among the student, and the confusion is, let's say I have a voltage source. Let's say I have a voltage source. This is 20 volt, and there is a current source, 5 ampere. Don't do such type of mistakes. Okay. And let's say I have a resistance here, 2 ohm. First of all, tell me this current. What is this current? What is this voltage? And how much power is absorbed by this resistance? Can you calculate? Tell me guys. What is the value of this voltage? What is the current value? And what is the power absorbed by this 2 ohm resistance? Can you tell me? Do it fast. Please tell me. Do it fast guys. Please tell me the value of the current I, the voltage across this resistance, and the power absorbed by this resistance. Can you tell me? Yes, the current will be 5 ampere. That's correct. Current is 5 and the V0 came out to be 10 volt. V0 is 10 volt and the power is I square into R, that is 50 watt. The power is 50 watt. That's correct. Current is 5 ampere because the current source will decide. Current source will decide the current. So the voltage came out to be 10 volt and the power absorbed will be I square into R, that is 50 watt. Okay, this will be the power absorbed. Now many students think that, sir, even the teacher will, sometimes the teacher tells you that you can, whenever this current source and voltage source are in series, what you can do is you can replace this with a current source, with a single current source. And the current source value is 5 ampere and connect a resistance here. Okay, you can do it like this. Now the current will be 5 ampere. You can see that the voltage remains 10 volt and the power is 50 watt. Okay, perfect. Whenever the voltage source and current source are in series, you can replace with a single current source and you can calculate the current and the voltage and the power in the resistance. But let me tell you guys, this circuit and this circuit are not equivalent circuit. If you are confused with this, that you can equivalently, you can make it like this. No sir, this circuit and this circuit are not equivalent. Why not? Why not? The problem is, if you look at this circuit, as far as this resistance is concerned, you will see no difference. The current and the voltage and the power in this resistance is same as in this resistance. Okay, so you'll see no difference as far as this resistance is concerned. But if you look at this circuit carefully, the power delivered to this resistance is 50 watt. And that power is entirely delivered by the current source. In this circuit, the power is entirely delivered by the current source. But in this circuit, if you look at this carefully, the power absorbed by this 50 watt power that is absorbed by resistance, this power is shared by these two sources. This power is shared by these two sources. Okay, you can see that this source is actually delivering 100 watt, 20 into 5. This current is 5 now. So it is delivering 100 watt and this source is absorbing the power 50 watt. This source is absorbing the power 50 watt. Out of 100, 50 is absorbed by this current source and 50 is absorbed by this source. So actually the current source is absorbing the power in this circuit. But if you replace the circuit like this source is delivering the power. So you can't say that this circuit and this circuit are equivalent. These two circuits are not equivalent. Okay, so remember. But as far as this resistance is concerned, if you want to calculate the current and the voltage and the power in this resistance, you can do it like this. There is no problem. As far as answer is concerned in resistance, you can do it. But remember, these two circuits are not equivalent. Okay, just remember this point. Okay, let's come back to the original topic. So I told you about the voltage. So there are voltage source and current source. Remember what this voltage source says. Let's say this is 20 volt. It says that the voltage difference between these 2 points is 20 volt. Can I say that this voltage is 20? Can I say that this VA is 20 volt? Tell me guys. Can I say like this? This VA is 20 volt. Say yes or no. Can I say like this? That VA is 20 volt. Say yes or no. Can I say like this? That VA, this point is A. So at this point the voltage is 20 volt. Can I say like this? Say yes or no. Answer is no. You can't say it. Why? Because this does not represent a point voltage. This represents the difference between A and B. The difference is 20 volt. A is at higher potential, B is at lower potential. Okay, so be careful about this point. Now what you can do is, let's say you have a voltage sources like this. Let me give you a question. 20 volt, and here you have a resistance of 10 ohm, and here you have a voltage source of 30 volt. Can you calculate the current in this? Tell me guys, can you calculate the current? Find I. Find I. What is I guys? Tell me. What is I? Tell me what is I? Please calculate this current I. How to calculate this current I? What is this current I? Can you calculate this current I? Hemant Singh 5 ampere, Ashok 1, no ground. Vishwanathan Murli, not possible, 5 ampere. Okay, let me tell you guys, you can't calculate the current here. Why? This is invalid circuit. This circuit is invalid. This is wrong circuit. Yes, this is invalid circuit. Why? Because if you look at this circuit carefully, between these 2 points, this source is directly connected. So this source will maintain 20 volt across this resistance. This source will say that the voltage across this 10 ohm must be 20, and this source will say that the voltage, because this source is also connected directly, this source is also connected directly between these 2 points. So what you can do is, you can say that this, if this is 30, this will also be 30, okay, because this is directly connected here. So this source will maintain 30 voltage difference here, and this source will maintain 20 voltage difference here. Between any 2 points, you can't have 2 voltages at the same time. 2 voltage difference you can't have. Okay, you can't say that the voltage difference is 20 or 30. No, sir. So remember, this is invalid circuit. Okay, this is invalid circuit. So according to this circuit, you can say a statement, you can make a statement, 2 voltage sources of different value can never be in parallel. 2 voltage sources of different value can never be in parallel. Okay, 2 voltage sources of different value can never be in parallel. But if they have the same value, they can be in parallel. Okay, if they have the same value, let's say this voltage is 20 volt. Let's say this voltage is 20 volt. Now tell me, if this is 20, now tell me how much current will flow. Now this is a valid circuit. This source will also maintain 20, this will also maintain 20. It means this voltage is 20. This voltage difference across this resistance is 20. So the upper point is at higher potential, lower point is at lower potential. Now tell me how much current will flow. How much current will flow? 20 by 10, that is 2 ampere. So now the current came out to be 2 ampere. I is equal to 2 ampere. Is it fine, guys? Tell me. Have you understood it? So if the voltage sources have the same value, then you can connect them in parallel. Okay? Then you can connect them in parallel. Now, there are some students who think that, sir, okay, I can say that this is 2 ampere. Now, can you calculate how much current is supplied by this source only and how much current is supplied by this source only? Can you calculate that? Out of this 2 ampere, okay, using symmetry you can say, because the structure is symmetric, so you can say that out of this 2 ampere, 1 ampere is supplied by this source and 1 ampere is supplied by this source. Using symmetry you can say. But if you want to apply superposition, let's say, if you want to apply superposition theorem, can you apply superposition theorem here? Can you calculate this current using superposition? There are 2 sources. Can you apply the superposition here? Tell me, guys. Say yes or no. Can you apply superposition here? Tell me everyone, can you apply superposition? Let me get some space. Okay. Tell me, can you apply superposition here? Answer is no, sir. You can't apply superposition here. Why? Let's apply the superposition. Let's try to apply the superposition. Okay. Let's try to apply the superposition. Now, if you apply superposition, you have to sort it. First take this source only and you have to sort it. Okay. The circuit will look like this. The circuit will look like this. This is 20 volt and you can sort it here. Okay. And this is 10 ohm. Now tell me about this current I. Can you calculate this current I1 due to this source only? How much current will flow due to this source only? Answer is you can't calculate. This is again a wrong circuit. Why it is a wrong circuit? Okay. Why it is a wrong circuit? Yes, Chandrasekhar, I'll tell you. I'll tell you if what will happen if you change the polarity. Okay, I'll tell you that. But before that, now this is again a wrong circuit. Why wrong circuit? Tell me guys. Why wrong? This is again a wrong circuit. You can't solve it. This is against the basic laws of the nature. The problem is this voltage source will maintain 20 voltage difference between these 2 points. Okay. This will maintain 20 voltage difference between these 2 points, and this voltage source will say that I will maintain a difference of 20 volt. But this source will, this short point will say that the voltage difference between these 2 points must be 0. So this side is saying that the voltage difference must be 0, and this side is saying that the voltage difference must be 20 volt. So two voltages cannot happen at the same time. Okay, two voltage differences cannot be there at the same time. So that's why this is a wrong circuit. Or you can say there are two sources in parallel. One has 20 voltage difference and one has 0 voltage difference. Now you can say also that, nah, you can treat this as a source of voltage source of the value 0 volt. Okay. So what you can say is, you can say that there are two sources of different value and they cannot be in parallel. So you can't apply superposition here. Okay. So be careful guys. In this circuit, you can't apply superposition. You can't check how much current will flow through superposition. Now, there is one more doubt. One student asked me, sir, what will happen if I change the polarity? Can I calculate the current now? If I change the polarity like this, tell me how much current will flow? Answer is again, this is a wrong circuit. Why it is a wrong circuit? Because this source is maintaining a 20 volt difference with this polarity, upper point with a higher potential, lower point has lower potential, and this source is maintaining this voltage difference. Okay. So it has opposite polarity. So you can't say that. This is 20, this is minus 20. So at the same time, you can't have two voltages. Okay. So again, this is invalid. So be careful about this. I hope you understood it. Okay. So be careful about the voltage sources. Two voltage sources of different value can never be in parallel. A voltage source can never be short circuited. A voltage source can never be short circuited. An ideal voltage source can never be short circuited. Okay. It will again violate the basic laws. Okay. Should have same polarity and same voltage. Yes, you should have same voltage value and same polarity, then only it's a valid circuit, otherwise it will not be a valid circuit. Now let's come to the current source. If you look at the current sources, let me write it here. If you have current sources, let's say this current source is of 5 ampere and this current source of 6 ampere, can you say that it is a possible circuit? Tell me guys, there is some circuit here, and in that circuit, in some branch, these two sources are connected. Can you say that this is a possible circuit? Again, this is a wrong circuit. Why it is a wrong circuit? Tell me guys. Because this current source will say that I will take 5 ampere and I will give 5 ampere without any compromise. Okay, without any corruption, I will take 5 ampere and I'll provide 5 ampere. This 6 ampere says that I will take 6 ampere only and I will provide 6 ampere only. It means it is providing 6 ampere and it is taking 5 ampere only. So there is a difference of 1 ampere. Where that 1 ampere will go? There is no other path. So it's an invalid circuit. So you can say that the current source of different value can never be in series. Current sources of different value can never be in series. Okay. If you have different value current sources, they cannot be in series. Just remember this point. This is again invalid circuit. But if this is 5 and this is also 5, then it is valid. Okay. If this is 5 and this is also 5, let's say this current is a 5 ampere. Okay. Now it's a valid circuit and the resultant current is 5 ampere again. This will take 5, this will provide 5. The upper current source will also take 5 and it will provide 5 amperes. So now this is a valid circuit. Now this is a valid circuit. So if the current sources have the same value, they can be in series. Otherwise they can't be in series. Okay. So remember this point. Should have same direction. Okay. Okay. Can I proceed? Okay. Let's proceed. Let's proceed further. Now let's say there is a resistance. Okay. Let's say there is a circuit. There is a resistance 2 ohm and there is a current source and there is a voltage source also. There is a current source of 5 ampere and a voltage source of 20 volt, let's say. Can you calculate this current? How much current will flow? Tell me guys. How much current will flow here? This is 2 ohm, this is 5 ampere, this is 20 volt. Can you calculate this current I? What is this current I? Tell me guys, what is this current I? What is this current I? This is 20 volt, this is 5 ampere in upward direction. And I want to calculate this current. Can you calculate this current? Can you calculate this current? Tell me guys, how much current is this? Yes, this current will be 10 ampere because this voltage is directly connected between these 2 points. So what this voltage source say? This voltage source say that since I am connected directly between these 2 points, so I will maintain a difference of 20 volt. So the upper point will be positive and the lower point will be negative and the difference will be 20 volt. So 20 by 2 will be this I. 20 by 2 is 10 ampere. Okay. So this current will be 10 ampere. Is it fine guys? This current will be 10 ampere. I hope you understood it. Okay. This current will be 10 ampere. It means the voltage source now dictate. So many students think that whenever the current source and voltage source are in parallel, you can replace this with a voltage source. You can replace this with a voltage source and you can calculate the current and voltage and power. Okay. Whenever the voltage source and current source are in parallel, you can replace it with a single voltage source and you can calculate the current and voltage and power. Now this circuit is not valid. I mean this circuit and this circuit are invalid. I mean they are not equivalent. They are valid circuit obviously. They are not equivalent. Many students think that this is the equivalent of this circuit. No sir. As far as this resistance is concerned, you can do it. Because in case of resistance, the current remains 10 ampere, voltage is 20 and power remains the same. Okay. Whatever power here, the same power you will get in this circuit. So as far as this resistance is concerned, there is no problem. There is no problem at all. But the problem arises when you say that this circuit and this circuit are equivalent. No sir. In this circuit, whatever power is absorbed by this 2 ohm, the entire power is delivered by this 20 volt source. But in actual circuit, whatever power is absorbed by this 2 ohm is not delivered by this voltage source only. Some power is delivered by this current source only, or it may be possible that entire power is delivered by this current source only. So according to that concept, you can't say that this circuit and this circuit are equivalent circuit. Okay. I hope you understood it. So remember this point. Whenever you have a voltage source and current source, as far as this resistance is concerned, if you want to calculate some current through the resistance or voltage across the resistance or power absorbed by the resistance, then you can do it. As far as answer is concerned, there is no problem. But this circuit and this circuit are not equivalent circuit. I hope you understood it. Okay. So let's proceed guys. I told you whenever 2 current sources of different value, they can never be in parallel. They can never be in series. Excuse me. Whenever 2 current sources of different value, they can never be in series. Okay. If they have same value, they can be in series. Okay. Now let me tell you one more point. Let's say I have a circuit here. This is some circuit and a current source is connected here. Can you open circuit a current source? Tell me. Can you open circuit a current source? Can you keep this current source open? Answer is no. A current source can never be open circuited. Why? Because it will take 5 ampere and it will give 5 ampere. But to whom it will give 5 ampere? It is open circuit, na? So you can say that this circuit is invalid again. A current source can never be open circuited. A current source can never be open circuited. Is it fine guys? A current source can never be open circuited. Remember this point. If you understood this point now, because the current, it will take 5 ampere and it will give 5 ampere. But to whom it will give 5 ampere? There is no way. There is no path. So this is invalid circuit. Now, if you have understood this, can you calculate, can you tell me the current in this resistance? This is 5 ampere and this is 5 ampere. There are 2 current sources of same value in series, 5 ampere and 5 ampere. What is the current in this resistance? Can you tell me guys? What is the current in this resistance? What is the current here? Can you tell me? Everyone. Tell me the amount of current. Tell me how much current will flow through this 2 ohm. Yes, it is 5 ampere. This current is 5 ampere. That's correct. But can you apply superposition? Can you apply superposition here? Say yes or no. Can you apply superposition here? Tell me, guys. Can you apply superposition here? Can you calculate this current using superposition? Tell me, everyone. Can you calculate this current using superposition? Can you calculate current using superposition? Answer is no. You can't apply superposition. Let's try to apply the superposition. If you apply the superposition, take this current source first and deactivate this source. If you deactivate this source, it will be open circuited. Okay. So if I keep this source open, the circuit will look like this. I am applying superposition theorem. The circuit will look like this. Okay. And I need to calculate the current due to this current source. Obviously, this is an invalid circuit. Why it is an invalid circuit? Because a current source can never be open circuited. So it's an invalid circuit. Okay. Just remember this point. I hope you understood this case. Okay. So I told you about the voltage sources and current sources. What are the properties of voltage and current sources? Now let's come to the dependent sources. Now the dependent sources, what is the meaning of dependent sources? Obviously, since the name itself says it's a dependent source, it means its value will depend on something. Let's say its value is 20 I1. Now what is this I1? Its value is depending on I1 value. Now what is this I1 value? I1 is a current in some branch. In what branch? In which branch? The circuit in which this dependent source is connected, in that circuit, it might be possible that there are so many branches. In some branch, the current is I1 and this source depends on the current I1. That's why I call it dependent source. It means its value depends on the other value. Sir, can you find the equation resistance of resistor circuit you have drawn? Which one? Can you find the equation resistance of which one, Vishwanathan? Which resistance? This resistance. No, you can't write equation. You can't write KVL here. Okay, no, you can't write KVL. The problem is the voltage across the current sources. Using symmetry, you can say this voltage is 20. This voltage is 10 volt, not 20. This voltage is 20. Tell me, guys, this voltage is 10 volt. So what you can do is, you can distribute this 10 volt 5 across this and 5 across this. Because of symmetry, you can distribute this. Otherwise, there is no way of distributing the voltage. Otherwise, there is no way of distributing the voltage. Okay. Yes. Okay. In the yellow circuit. Okay. In this circuit, you want to write the KVL. No, sir, you can't write the KVL. This is invalid circuit. This circuit is invalid. KVL is not applicable here. You can't apply KVL here. This is an invalid circuit. Okay. Okay, let's come to the topic. So I told you the dependent sources. The dependent sources means its value is dependent on some other value. Okay, let's say this is 20 I1. It means the value depends on I1. Now what is this I1? I1 is the current in some branch. Which branch? There might be some circuit. In that circuit, this source is connected. In that circuit, there are so many branches. So in one particular branch, the current is I1, and on that current, this source is dependent. Similarly, the dependent current source. Dependent current source can also be dependent on some voltage or some current. Let's say this is 20 I1. It means it is also dependent on I1. Okay. So I1 is some branch current. So that's why we call it dependent source. Okay. Okay. Let's proceed, guys. Let's proceed. Now I want to tell you about the concept of KVL and KCL. Okay. The concept of KVL and KCL. Now it is very important. Many students don't know this KCL concept. It seems very easy to everyone because the student think that, oh sir, it's very simple. How can you say that they don't know this KCL? Yes, that's truth. KCL is the most difficult topic in network theory, especially in AC circuits. Especially in AC circuit, KCL is the most difficult thing that you make mistake in KCL. Okay, I'll take some questions here. Okay, so first let's try to solve some questions. Let's say I have a circuit like this. Let's say I have the circuit like this. I want you to tell me, this is a simple question. I'm taking a simple question first. Okay, let's say this is 5 ampere. This is 2 ampere. 5 ampere, 8 ampere, this is I, 20 volt, 4 ohm, 6 ohm, 10 ohm, 20 ohm. Okay, let's say this is the circuit. I need to calculate this I. Please calculate the current I. Please calculate the current I. It's a simple question. It's a simple circuit. Now tell me how to calculate the current I. Everyone know about KCL, na? The entering current must be equal to leaving current at any node or any junction. Entering current must be equal to leaving current. Everyone know that. Everyone knows that. Now, if you look at this node or this junction, or this junction, you can't apply KCL at these junctions. Why? Because at this junction, this current is known, but this branch and this branch current are unknown. So you can't apply. If there are two unknown, na, you can't apply KCL. You can't apply KCL at this junction because it has two unknown. This point, this side and this side. You don't know the current of this. Similarly, you can't apply KCL at this junction. Why? Because you don't know the current of this branch and this branch. That's why you can't apply KCL at this junction. Now, how to solve it? At any junction, you can see there are more than two unknowns. Two or more than two unknowns. So you can't apply KCL. So in such situation, what you can do is you can say that any closed circuit will also act like a node or a junction. Okay. So any closed circuit will also act like a junction. Now this statement is very powerful. Okay. Any closed circuit will also act like a junction. Now tell me, if it is a junction, the entering current must be equal to leaving current. How much current is entering? Tell me guys. Entering current is I and this 5. So I plus 5. This is entering current must be equal to leaving current. How much current is leaving? 8 plus 5 plus 2. 8 plus 5 plus 2. Okay. So this way you can say that I is 10 ampere. So this was simple question. This was easy question and you can understand that. But let me modify the question again. Okay. Let me modify it. Let's say the circuit is like this. Let's say the circuit is like this. Let's say the circuit is like this. Let's say I have this circuit. Now, can you tell me how much current will flow here? I. Find this I. 10, 40 volt, 10 ohm, 20 volt, 5, 5, and 30 volt. Please tell me what is this current I? What is this current I? What is this current I? Tell me guys. This current I is 0. This current I is 0. Why? Because this is a closed circuit. This is a closed circuit. In closed circuit, if there is some current which is leaving, there must be entering current. Then only this current can leave. So you can't say that this current will leave. So that's why this I is 0. According to KCL, this current is 0. Now, what I want to do is, I want to modify this circuit. Let's ground it here. Now tell me, will it be 0 or non-zero? Tell me guys, if I ground it here, will this current be 0 or non-zero? Tell me guys. Now if I ground this point, will this current be 0 or non-zero? Tell me guys, still 0 or non-zero? Is it non-zero now? Is it non-zero? Tell me guys, is it 0 or non-zero? If I ground this point now tell me, what is the value of this current? Tell me. Yes, this time also it will be 0. Why? Why it will be 0? Because if you look at this, you say, sir, now this is a closed circuit. In this closed circuit, if some I is leaving, it can enter from the ground. So KCL is satisfied for this closed circuit. No sir, it is not satisfied. Why? Because ground is also a node. Ground is also act like a node. If some current is leaving from the ground, there must be the same current which should be entering in the ground. But there is no other point which is connected to ground. So you can't say that the current will leave from the ground. No sir, you can't say that. Okay. So you can't say that the current will leave or this I is non-zero. No sir, this I will not be non-zero. Or what you can do is leave this part, leave this side. Okay, don't look at this side. What you can do is look at this side. This is again a closed circuit. This is again a closed circuit. In this closed circuit, the entering current must be equal to leaving current. Since there is no leaving path, if this current is entering, let's say, the same current must leave, but there is no leaving path. That's why this I has to be 0. Is it fine? this I has to be 0. I hope you understood it. This I has to be 0. So this I will be 0 if one side it is grounded. Now, can you tell me if I ground this side also? Now, will this current be 0 or non-zero? Tell me. Will this current be 0 or non-zero? Tell me, guys. Will this current be 0 or non-zero? Okay, tell me. Will this current be 0 or non-zero this time? 0 or non-zero? Tell me, everyone. Will this be 0 or non-zero? Now, this current has to be non-zero. Now, this current can flow. Now, this current can flow. I mean, you have to calculate. If the current came out to be 0, it's a just, I mean, it may not be 0. I should say like that. It may not be 0. Now, it may flow. Okay? It may flow. Why? Because now KCL is satisfied. If you look at this closed circuit, whatever current is leaving here, the same current will enter from the ground here. Okay? In the closed circuit, whatever current, let's say I is leaving, so I will enter from this ground. Now the KCL is satisfied for ground also. If I is leaving from the ground, I will enter here. Is it fine, guys? I will enter in the ground here. So arrow should be opposite. Okay? Is it fine, guys? So you can see that the KCL for the ground is also satisfied. Whatever current is leaving the ground, that the same current will enter here. And the KCL for this closed circuit is also satisfied. You can see that if I is entering in the closed circuit, the same current is leaving from the closed circuit. So now KCL is applicable everywhere. So you can say that I may not be 0 this time. Okay? I may not be 0 this time. But it might be possible that this current came out to be 0. It might be possible because of these point voltages. I mean, it might be possible that this voltage and this voltage is same, or maybe the voltage across this 10 volt is 0. If the voltage across this resistance came out to be 0, then you can say this I will be 0. But this I is not 0 because of KCL. According to KCL, this has to be non-zero. But if you try to solve it, it might be possible that the circuit parameter are such that, the circuit element value are such that the voltage across this resistance came out to be 0. That's why the current is 0. It means the current is 0 not because of KCL. The current is 0 because of the circuit parameter. Current can flow. Current can flow. Okay, this current may be non-zero this time. Current can flow. And remember, the good point is whatever current this I is, the same current will be this current and the same current will be this current. Okay, just remember this point. Okay, I hope you understood it. Now, let me give you one more point. Let me tell you one more point. Let's say this is the circuit we have, and what I did is, this is the circuit we have. What I did is I connected current source here, 5 ampere. Now tell me about this current I. What is I? Tell me about I. I connected 5 ampere here. Tell me what is the value of I? Can you calculate the value of I? Tell me, guys, what is the value of I? Can you calculate the value of I? Say yes or no. Can you calculate it? What is the value of I? Tell me, is it 5 ampere? How many of you think that this is 5 ampere? How many of you think that this is 5 ampere? Okay, everyone is saying 5 ampere. Answer is invalid circuit. This is invalid circuit. This circuit is wrong. This is invalid circuit. Why it is invalid circuit? Tell me, guys. Why it is wrong circuit? This circuit is invalid. This circuit is wrong because look at the KCL. Look at this closed circuit. If 5 ampere is leaving, there must be entering current. There is no entering current in this closed circuit. So you can't say that the current will leave. That's why this circuit is invalid. You can't take current source here. Current source will make it wrong. Current source will make it 0. Is it fine, guys? That's why this current source value, this current source is making the circuit invalid. Is it fine? Have you understood it? I hope you understood it. Let's proceed, guys. Okay, let's proceed. So I told you about the KCL. Now let's take some more questions. Let's take some more questions. Let's say the circuit is like this. Let's say there is a big circuit and let's say I have this circuit. Okay, I think it's enough. On this side, you have the circuit like this. Okay, let's say this is the circuit we have. This current source is of 5 ampere. This is 44 ohm, and this voltage is, let's say, maybe 40 volt. Okay, this is 20 volt. This is 2 ohm. This is 6 ohm, 20 volt, 10 ohm, 5 ohm, 8 ohm, 16 ohm, 20 volt. Let's say this is the circuit I have. Okay, these values are not important for me. Okay, now what I want to do is I want to calculate this voltage V0. What is the value of V0? Find V0. Now this circuit looks difficult. Many students will leave this question. This circuit looks difficult. Okay, now how to solve this? How to calculate this V0? To calculate this V0 with this polarity, I need to calculate this direction current I. Then only you will get this polarity of voltage. Once you get this current I, then you can say that this I into 5 will be this V0. Now how to calculate this I? Using KCL. Now how to apply KCL? Look, this is a closed circuit. You can treat this circuit as a closed circuit. Now, if somehow you can calculate how much current is entering in this circuit, and the leaving current, if you equate them, you can calculate the I. Is it fine? If you can calculate the entering current and the leaving current, then you can calculate the I. Now tell me, how much current is entering? From this current source, you can say that the 5 ampere is entering in this closed circuit. So entering current is 5 plus. Tell me about this resistance. This resistance has the 4 ohm value, and the voltage is plus here, minus here. Now tell me, current will flow in this direction. How much current will flow? 40 upon 4. 40 upon 4 is 10 ampere. Okay, 40 upon 4 is 10 ampere. So you can say that the current will enter here. That current is 10 ampere. Okay. Now what about this current, this branch current? Can you calculate the branch current? Tell me guys, how much current will flow here? How much current will go? Okay, this voltage is 40. It means the voltage difference between these 2 points, because this resistance is connected in parallel with this branch, so this voltage difference must be of 40 volt. Okay, this must be of 40 volt. Now if you apply the KVL at this branch, you can say that this point voltage must be 20. Okay, this voltage difference must be 20, not this point voltage. This voltage difference must be 20. Okay, the voltage across this R should be 20. Wait a minute. The voltage difference between these 2 points, voltage difference across this R must be 20. Because if it is 20 plus 20, it will become 40. Okay, the total difference is 40 now, according to the parallel combination. So you can say if this is 20, this must be 20. 20 plus 20 will become 40 now. That's why this voltage should be 20 volt. So if this voltage is 20 volt, how much current it will enter? Tell me, how much current will enter from this branch? 20 by 2, that is 10 ampere. So you can say the entering current is 10 ampere from this side. Is it fine? So the total entering current is 10 plus 5. That must be equal to leaving. Leaving current is not there. Leaving current is 0. There is one more entering current I. Okay, you can see that I is entering, 5 is entering, 10 is entering, and this 10 is also entering. So you can say that the total entering current is this and leaving current is 0. So you can make leaving current as 0. So I came out to be minus 25. It means in this direction, the current is minus 25. Now the voltage V0 is equal to 5I. According to the polarity, according to this polarity, V0 came out to be 5I. Now I is minus 25, so it will be minus 125 volt. Is it fine, guys? Have you understood it? Say yes or no. Okay. So this I came out to be minus 25. This I came out to be minus 25, and the voltage across this will be minus 125. Is it clear, everyone? So look at this circuit. This is again a closed circuit. I mean, there are some students who think that, okay, I know KCL. You can treat a closed circuit like a junction, like a node. But whenever I change the situation, they are not able to think that this is a closed circuit again. This is a closed circuit and this is a closed circuit. I mean, the same concept I am applying. I am applying the same concept. Entering current equal to leaving current. So you have to be careful. You have to understand how to apply this concept. This concept looks easy in this case, but the same concept will not look easy in this situation. Okay. So you have to be careful. Is it clear, guys? Can I proceed? Say yes or no. Can I proceed? Okay. So I told you about KCL. Now similarly, you can understand the KVL part. Okay. Similarly, you can understand the KVL. Now let's take some problem on KVL also, and then I'll go to the source transformation. Okay. Let's take some questions on KVL. What is the KVL? KVL says that in a closed loop, if you move in a closed loop, the total sum of the voltages is 0. If you move in a closed loop, the total sum of the voltages will be 0. That's correct. That is KCL. But let's say you move in an open circuit. Let's say you move in an open path. Okay. Let's say this is the circuit I have. Let's say I have this circuit. Here you have the dependent source. That dependent source is 10 V0. Let's take it 10 V0. This is 20 volt. This voltage is V0. Okay. This current is I1. On this current, this dependent source is dependent, 20 I1. Okay. This is 10 ohm. Okay. This is 2 ohm. This is 2 ohm. Okay. And this is 10 ohm. And I think this is 8 ohm. That's correct now. This is 8 ohm. Okay. This is 20 ohm, 10 ohm, 10 ohm, 20 ohm and 40 ohm. That's great. Okay. Wait a minute. Wait a minute, guys. Okay. Okay, wait. What I can do is, okay, let's make this, let's try to solve this question. First of all, I want to calculate this V0. Find V0. Find V0. This is not a KVL problem. This is a random problem. I design it randomly. I want to design something else. Okay. And the question becomes something else. Anyway, calculate V0. Okay. Calculate this V0. This is 40 volt obviously. Okay. This is 40 volt. Actually, I want to design something else, and the question came out to be something else. Okay. Anyway, let's leave it. I want to calculate this V0. What is this V0, guys? Can you calculate this V0? Tell me, what is the V0? What is the value of V0? Tell me, everyone. What is the value of V0? Let's see. What is the value of 20 I1? What is the value of 20 I1? Can you tell me? How much current will flow here? First of all, please tell me how much current will flow here. How much current will flow here? Can it be 0 or non-zero? Tell me, guys. Yes, this current must be 0. It means this 20 I1 has to be 0. There should not be current in this branch. If there is no current in this branch, it means this 20 I1 has to be 0. This 20 I1 has to be 0. If you make this 20 I1 equal to 0, then I1 must be equal to 0. Okay. I1 has to be 0. Is it fine, guys? It means I1 has to be 0. If you take I1 as 0, it means this current is 0 ampere. Is it fine? If this current is 0, it means this drop is 0. Tell me, guys. It means this voltage drop is 0. Say yes or no. This voltage drop has to be 0. Now, what is the voltage difference between these 2 points? the voltage difference between these 2 points must be 10 V naught. This voltage difference must be 10 V naught because this voltage is 0. So whatever the voltage difference between these 2 points, the same voltage will be appear here. So you can say the voltage difference between these 2 points must be 10 V naught. And according to this source, the voltage difference between these 2 points must be 20. So this 10 V naught must be 20. Is it fine, guys? Tell me. So V naught has to be 2 volt. Is it fine? V naught has to be 2 volt. Is it clear? Look, this is a very beautiful question. This source came in parallel with this source. So their values must be same. There is no resistance here because if there is a resistance, then the voltage across this resistance is 0 volt. So there is no need to take this resistance into consideration. So the voltage difference between these 2 points is 10 V naught. And according to this, this is connected in parallel with this 20 volt. If 2 voltage sources are connected in parallel, they must have the same value. That's why 10 V naught equal to 20. So V naught came out to be 2 volt. Is it fine? V naught came out to be 2 volt. And look at this. This current has to be 0 according to KCL. That's why I1 has to be 0. Is it fine? So this question was a very good question. I hope you understood it. Is it fine, everyone? Can I proceed? Say yes or no. Tell me. Tell me, guys. Okay. Now let's come to the next question. I want to take a question on KVL. In a closed loop, you can always apply KVL. Okay. There is no problem in a closed loop. But whenever the loop is not closed, then what will happen? Okay, let's take a problem. Let's take a question. Whenever the loop is not closed, let's say. Now, how to apply the KVL? Let's say this is the question I have. I can design my own question. Okay, I can design any question on any concept. Okay, let's say this is 5 ampere. This is 2 ohm, 6 ohm, 2 ohm, 20 volt. This is 20 volt, 10 ohm, 4 ohm, 6 ohm, 8 ohm, and 36 volt. Okay. This point is A and this point is B. I want to calculate VAB. What is VAB? VAB. We need to find VAB. How to find VAB? There are 2 points, A point and B point. How to calculate the voltage difference between these 2 points, A and B point? How to calculate that? How to calculate that? Tell me, guys. To calculate the voltage difference, what you need to do is you need to apply KVL. Okay. Now, how to apply KVL in open path? Because between A and B, there is no closed path. There is an open path. So what you can do is first you calculate, you take any path, na? You take any path. In that path, you must have the voltage across each element. You must have the voltage across each element. Then only you will be able to find VAB. Okay, otherwise you can't find VAB. So what you can do is, first you calculate voltage across each element. You start from A and you go to B. Take any path. Let's say you follow this path. Okay, you follow this path. So in this path, you have to find the voltage across each element. First, you have to find the voltage across each element. How to find the voltage across each element? It's simple. It's simple. Tell me, guys, what is this current? This current is 0. We know that this current is 0 because of KCL. It means this has to be 0 volt. This has to be 0 volt. Okay. This voltage has to be 0. Now, if this voltage is 0, now we can say that this current is 5 ampere. The same current will make a loop here. Because this current is 0, so whatever current 5 ampere is taking this source, the same current will come from this side. Okay, 5 ampere, because this current is 0, so entire 5 ampere will be taken by this source. Okay, so this current is 5 ampere. So according to this 5 ampere, this is 10 volt, this is 30 volt. Is it fine? And this is 10 volt. Is it clear, guys? Is it clear? So according to this 5, I have written the voltage across each element. And this current is 0. Now come to this circuit. In this circuit, there is no external current which is entering in this circuit. So what you can do is you can apply KVL in this closed loop to find this current I. Now tell me, what is the current I? 36 divided by the total resistance of this path. 36 divided by the total resistance came out to be 18. Okay, 36 by 18 is 2 ampere. So this current is 2 ampere. So what you can do is you can calculate the voltage difference. This will be 16 volt. This will be 12 volt. and this will be 8 volt. Tell me guys, is it clear? So we have calculated voltage across each element in this branch also. We have calculated voltage across each element in this branch also, in this loop also. So what you need to do is, now you have to apply the KVL. You start from A point and reach to the point B while writing voltage across each element. So let's start from A. VA. This point voltage is VA. Whenever you go from plus to minus, you subtract the value. Now there are some teacher which follow the opposite convention. Whenever they go from plus to minus, they add it. Okay, they add it. I don't follow that. Okay, I follow the opposite way. If you follow the opposite, then it's your problem, guys. I follow the natural way. This is the natural way. Let me tell you, there are some books which resistance will always provide you the drop. Okay, so whenever you move in the direction of current, it means it will provide you a drop. Drop means subtraction. So whenever you go from plus to minus, you have to subtract the voltage. Okay, but if you have understood this way, you can write this way also. I mean, there is no problem with this, but I don't follow this way. Okay, so but there are some teachers which follow this way also. There is no problem. I mean, the answer will be same. So I'm not saying that this is wrong, but I follow the natural way. So the natural way say, at this point, if it is VA minus 30, since you are going from plus to minus, again minus 20, then you are going from plus to minus, minus 10, and then this is plus 20, minus 0, plus 12, and plus 16 equal to VB. Okay, so you have followed this path. You have started from A, subtracted this voltage VA minus 30, minus 20, minus 10, plus 20, minus 0, plus 12, plus 16 equal to VB. Now you can calculate VA minus VB. Okay, now you can calculate VA minus VB. So VA minus VB will be, this 20 will be cancelled, and you can see that this is 40. So this minus 40 will go on the other side, it will become plus 40 minus 28. So it will be 12 volt. Is it fine, guys? So this way you can apply KVL. So KVL is not only applicable in closed loop, it is also applicable in open loop. Okay, you can start at any point and you can go up to any point. You take any path, just avoid the path which has the current source. That's why I have avoided this path. The current source path, because we don't know the voltage across the current source. We have to calculate that voltage first by taking the loop voltage equal to 0. Let's assume this voltage as V. So what you can do is you can apply the KVL in this loop and calculate the V first. So first we have to calculate the V, then we have to go like this. So why to calculate V? Why to increase one more step? So what you can do is you can avoid the current source path. Okay, you can avoid the current source path. You can go like this. From A to B, and you must know the voltage across each element. So just by adding or subtracting, you can reach to point B, and you can write the KVL like this. This is again a KVL. Okay, so I hope that you understood the concept of KVL. Now there is a concept of source transformation. Everyone know about the source transformation. The source transformation says that whenever you have a voltage source in series with resistance, what you can do is you can convert this voltage source into current source like this. Okay, you can make the current source like V upon R. This will become the current source in parallel with this resistance R. Okay, so it will be a current. You can convert this in current source. Now direction of the current source. Direction of the current source should be the direction of the voltage source. It means from minus to plus. From minus to plus, if the voltage source is upward, then the current source will also be upward. Okay, so you can convert a voltage source into current source and current source into voltage source. Okay, you can do it like this. Whenever you have a current source in parallel with resistance, what you can do is you can connect this resistance in series with a voltage source. You can convert this current source into voltage source. Okay, so it's an easy step. You can do it. What is the proof of this? Proof will be understood in Thevenin and Norton theorem. Okay, so I don't want to go to the Thevenin and Norton theorem right now, but just remember this point. This is a source conversion. You can't apply source conversion everywhere. Okay, there is a limitation of source conversion. Let me tell you where you can't apply the source conversion. Let's say you have a circuit like this. Let's say you have the circuit like this. This is 20 I1. Okay, and 20 volt, 2 ohm, and let's say there is one more resistance, I call it 2 ohm. Okay, and this current is I1. This current is I1. And here on this side, let's say you have a resistance of 10 ohm, and let's say this is also 10 ohm. This is 20 ohm. Fine. Now, please tell me, can you convert this voltage source into current source? Can you convert this voltage source into current source? There is a resistance in series with a voltage source. So obviously you can convert this into a current source. Now, can you convert it? Say yes or no. Can you convert this voltage source into a current source? Tell me guys. Answer is no. You can't do it. Why not? Why not? Why can't you convert this current source into voltage source into current source? The problem is this I1. Problem is this I1. Because the branch current will decide this source value. If you convert this branch, you will not be able to show this current I1. That's the main problem. Okay. So whenever some branch current, some branch current or some branch voltage, let's say, some element voltage, let's say, is deciding the source value. Whenever the branch current or some element voltage is deciding the source value, try to avoid the source conversion of that branch. Okay, try to apply the source conversion on that branch. Okay, you don't need to apply the source conversion on this branch. Okay, so remember this point. Okay, remember this point. So what you can do is either you change the shift of dependency. Okay, either you change the you shift this current now. This source is dependent on this current I1. So what you can do is you can change the shift, change the dependency. Shift the dependency. How to shift the dependency? This is 20 I1. If somehow you can replace this branch current to somewhere else, then you can apply the source conversion. Now, how to shift that? Let me tell you guys. Let's assume that this is 0. Let's assume that this is 0. If it is 0, what about this voltage? Can you tell me that this voltage? What about this voltage, guys? Can you tell me this voltage? This voltage is 20 plus this 2I1. So this voltage is 20 plus 2I1. Is it fine? 20 plus 2I1 is this voltage. Is it fine, guys? Now, if this voltage is 20 plus 2I1, what about this current? This is 0. I have assumed that the lower point is at 0 volt. So if this is at 0 and this voltage is at 20 plus 2I1, you divide it with 2 to get this branch current. So this branch current came out to be 10 plus I1. Okay, this branch current came out to be 10 plus I1. Fine. You get this branch current 10 plus I1 and this current is I1. So the total, now you can say that this I1, you can calculate the I1 value from this branch. This branch current has to be 10 plus 2I1. Okay, from this branch current you can calculate I1 and then this source will be decided by I1. So you have shifted the dependency from this branch to this branch. I hope you understood it. Now you can apply source conversion. Now you can apply source conversion. Is it fine, guys? So it is a very nice step. It is a very nice step. What you have done is, previously it was dependent on this current I1. So the problem was you can't apply source conversion here. Why? Because this branch current is deciding this voltage source. That's why you can't apply the source conversion here. So what you can do is you can shift the dependency. You can shift the dependency. How to shift the dependency? What you have done is, using this I1 current, you have calculated this point voltage, and with the help of this point voltage, you have calculated this side current. Once you get this current in terms of I1, so this current in terms of I1 is 10 plus 2I1. Now you can replace this I1. Don't show this I1. Okay. Now you don't show this I1. Okay. This I1 is removed now. It means now this I1 is decided by this branch current. Once you calculate this branch current, that branch current must be 10 plus 2I1. You find the value of I1 and put it here. You can calculate the dependent source value. So what you have done is you have shifted the dependency of this branch, okay, on this source. Is it fine? Or this source dependency on this branch. You have shifted that. Now this source value will depend on this branch current. Now you can apply source conversion here. Is it fine? because this branch will remain intact. If you apply source conversion here, this branch will remain intact. So this current will be 10 plus 2I1. It will remain as 10 plus 2I1, and you can calculate I1 value from here and you can put it here. So please be careful. Be careful about this concept. If you have not understood this concept, leave it. Okay, leave it. Don't apply source conversion in this situation. Don't try to shift the dependency. Don't shift the dependency. What you can do is, you keep this current I1 here. No problem. Just remember, don't apply source conversion here. Okay. I hope you understood it. Now, the problem is how to solve such type of problem. How to solve it? Let's say I want to calculate this current I. How to solve it? How to solve this type of problem? So to solve this type of problem, what you can do is you can apply nodal. There is a concept of nodal analysis. Okay, nodal and mesh. Okay, so maybe the nodal and the mesh I will take in the next class. Okay, I mean in the next session, because the time is over. I have to take one more class at 6 p.m. or maybe 6:15. I don't know. But my part is up to this time. I mean, I have to cover the nodal part also. In these 2 hours, I have to cover the nodal part also, and then I have to tell you about the AC circuit. But in tomorrow's class, because on tomorrow also, in the first half of the lecture, I have 2-hour session. So in that session, I will cover the nodal part also, and the AC, basics of AC circuit I will cover. Okay. So let me contact Fanindra sir, because from this point onward, Fanindra sir will take the class, and Fanindra sir will teach you about some new concept. Okay, so don't forget to like the session, guys, because the like is 99. I want to make the century. Okay, so please make a century of likes. Only 99 likes are there. Okay, so let me contact Fanindra sir so that he can join in. Wait a minute. There will be a glitch of like 2-3 seconds, okay, or maybe 10 seconds. So don't worry, guys. There will be a glitch of maybe 10 seconds, and then sir will join. And let me tell you the nodal part. I'll tell you the nodal part, nodal and mesh in the next class, in the next session, which will be on tomorrow. The first half on tomorrow will be on nodal and AC, basics of AC circuit. Okay, so sir will take from, I think sir will take the transient part or maybe something else. So wait a minute, guys. There will be a glitch of 10-15 seconds. Okay, so please wait.
Hello, welcome to India's most comprehensive e-learning platform, BYJU'S Exam Prep, and also special welcome to all ECE and electrical and instrumentation students. I hope you guys really enjoyed a lot the morning session as well as the post my session, that is Ashu Jangra session. In fact, on the circuit theory, I have seen a lot of concepts, lot of messages from you in the chat box stating that you learned a lot of concepts in today's session, correct? So, good evening to every one of you. Good evening, Sachasri. Good evening, Krishna Murali Singh. Good evening, Krishna Veni. Good evening, Banot. And good evening to one and all. And we will going to take the next part of the circuit theory. Of course, it will be a 2 hours of session. And I plan to cover the theorems. However, we will also discuss some of the new concepts in today's lecture. I will explain how a single question can be solved by using number of ways. So you will also feel so much of interesting. Naturally, we will use all our ability in these sessions because we have written gate multiple times. Either Ashu Jangra sir, even Rakesh sir and me, we have written the gate multiple times and top. So we have a lot of techniques with us. So we will be ready to share that. You must have the patience. So please let me know, every one of you in the comment section, are you guys so much energetic or not? In this evening, we are going to rock with the second part of the circuit theory, that is the theorems, which is very, very valuable and which is very interesting also. Clear? Neha, good evening, and Hemant Krishna, good evening. Please let me know, all of you are interested to get the new concepts or not. Yes, Ravi is saying yes. Lokesh, we will start. Definitely we will start. Once we start, then it is Rajdhani Express. We never stop. Okay. So you have to take a break, right? You breathe, in fact. Correct? So topic. Navneet, we are going to start, theorems. We will going to discuss the theorems, right? So I think 10 minutes break was given to you, or maybe you might refreshed well. Well, Rajashika, thank you very much, right? So as I said, we are readily available to discuss the marathon session. And presently I am here to discuss about the circuit theory part 2, that is theorems. Well, So for the new students, you all can see my credentials. My name is Panindra. All put together, I have 11 plus years of teaching experience. So far, I have guided more than 50,000 students in the subjects of control system, circuit theory and industrial instrumentation. Clear? So without any further delay, as Lokesh is very interested to know, very interested to start the session, let's start the session of the day. But before going to discuss about the theorems, I would like to ask a general question. How many marks you can expect from theorems? Every one of you must answer this. Comment box should blast today. So all of you please mention in the comment section how many marks you can expect from the theorems. According to my experience, you will definitely get one question and you will be lucky if you get a question from the 2 marks session, correct? So minimum you will be having 2 marks, and if you are lucky enough, there might be a chance to get a 3 to 4 marks also. So therefore this section is very important. I will try to cover all associated topics of the theorems in one session. So let's get into the topic. Very good, nice Raviteja, nice, right? So in theorems, especially as far as the gate syllabus is concerned, let us discuss only the gate syllabus, but let's go deeply into the gate syllabus. Okay, so I will try to cover the revision. Along with the revision, we will also see questions, and in the questions also, in each question I will tell you how to apply number of techniques so that you will enjoy that, right? So what are the theorems we have? In fact, we have several theorems. Apart from these theorems which are visible on the slide, I have developed some more theorems, but of course I cannot discuss those theorems in the class now, right? So the very first thing is the superposition theorem. Starts with the superposition theorem, which is very fundamental, and you must know this one whenever a complicated circuit is given. Clear? So and the second is Thevenin's theorem and Norton's theorem. Now every one of you tell me in the comment section, do you require to study Thevenin theorem and Norton's theorem separately to solve a question? No. If you are good with the Thevenin's theorem, complete the entire Thevenin's theorem and then apply the source transformation to the Thevenin theorem, then you will get the Norton's theorem. Clear? So this is a very easy technique. Anyway, I will going to tell you all these things in a detailed way. Very good Raghuram, very good Nirmal, very good Lokesh, very good. One is sufficient. Anyway, the third one is maximum power transfer theorem. When maximum power transfer theorem comes, DC circuit, handling the DC circuits is very easy. But handling the AC circuits is quite logical and you require more basics also. So we will discuss that. And then reciprocity theorem, which is very important. Most of the students, they struggle here. I will let you feel very comfortable. And then Milliman's theorem, Telegan's theorem. And the last but not the least, substitution compensation theorems. Though many students don't give importance to this, the reason is these theorems, though that technically they are there in the syllabus, you will never get a question from that. Even if you get a question from that, you can answer that question by using the other theorems. Okay, right, very good. Yes, Satya Krishna, correct, you are right. So we will all the way discuss, put our effort to discuss all these important theorems in these 2 hours of session and try to cover 2 to 4 marks. Okay, so if you are getting 4 marks, then you are the luckiest person, but minimum you will be having 2 marks. Clear? So well, yes sir, AC circuit somewhat confusion. Today at the end of the session, I will ask the same question to you, Raja, and definitely you feel that it is very easy. Okay, trust my word and mark my words, right? Prasanna Kumar, thank you very much, Prasanna Kumar, right? So whenever you are feeling that it is buffering, I sincerely suggest refresh it. When you refresh, then automatically everything will be clear. So well, let's start with the first topic of the day, that is superposition theorem. Clear? So I simply ask a question, when do you use the superposition theorem? In a simple way, not only superposition theorem, any type of theorem we will use in complex circuit. The purpose of theorems is to reduce the complexity of the circuit and to minimize your effort to get the answer very easily. Correct? So ultimately, what is the purpose of circuit theory, you tell me? Every one of you, there are almost around 70 to 80 students are there in the comment section. Tell me what is the use of the theorems, or what is the use of any technique, that may be KCL, KVL, Ohm's law, or else mesh analysis, nodal analysis, source transformation, and any equivalent concept, or else theorems, whatever you use, ultimately what is your importance, or why you are doing that, right, to make the circuit simple. Fine, let us say the circuit is simple. Now if the circuit is simplified, what you are going to get out of that simplified circuit? That is what I am asking. If the circuit is simple, out of that what you are going to get? So our ultimate aim is to find out the energy consumed by an element or energy dissipated by or energy delivered by an element. Clear? I'm not going to discuss whether that is a source or load, something like that. I'm saying that in circuit there are 4 to 5 elements are there. We need to understand what is the energy delivered by a particular element or what is the energy consumed by a particular element. So to know that, we need to use some kind of analysis in the circuits. And while we are proceeding for the analysis, theorems is a simple tool which is used to simplify the circuit. But ultimate objective is to know whether the energy is delivered by an element or whether the energy is consumed by an element. Clear? So now I will ask a question. If you want to find out the energy, how do you find the energy? So first of all, we must actually know what is the current that is flowing through any branch. You say in the total circuit, you can consider 10 elements or 15 elements. But if you want to know whether a element is delivering the energy or consuming the energy, first of all, you must calculate the current flowing through that. Correct? So when you know what is the current, then obviously you can calculate the voltage. Correct? So just it is current into impedance, then you will going to get the voltage. And when you get the voltage, then obviously you can calculate the power. Correct? So when you get the power and you know how much time you are operating with that current in that element, then the power calculation will going to give the energy here. Clear? Energy here. I hope this is very easy line, isn't it? So that means whatever the question you take in circuit theory, irrespective of the GATE exam, irrespective of the university exam, irrespective of the engineering service exam, either the question is find the current through a particular element or find the voltage across a element or voltage at a node or power consumed by the load or power delivered by the load or energy delivered by the source or energy consumed by the load. Am I right or not? All of you please tell me in the comment section. Is it correct or not? So the ultimate objective of any technique, this may be theorem or this may be source transformation technique, this may be KCL or this may be KVL or this may be equivalent circuit. So ultimate aim of the whole network theory is to provide the analysis to find out either the current or the voltage or the power, but ultimately we need to measure energy here. Clear? Yes, yes, yes. Getting interest now. So let's get into the first topic of the day, that is superposition theorem. Now you see, the principle of superposition theorem is it states that the voltage across or current through an element in a linear circuit. This is very, very important. And suppose if the given circuit is not linear, you should not use the superposition theorem. Whenever you are trying to use the superposition theorem, check whether the circuit is linear or not, whether the relation is linear or not. Clear? So, linear circuit is the algebraic sum of the voltages and current produced independently by each independent source. Excellent, right? So this is my definition. Of course, that's why you are feeling like independent like that. So in a simple way, if you have 4 sources or if you have 3 sources in the circuit and you require to find out the current through a particular element in the circuit, then every time we activate only one source, and get the response in that particular branch because of that one source, and then finally we will take the total summation of all the currents. That's it. Clear? So this is a simple statement. But how do you apply this superposition theorem? Guys, as I said, we will going to revise the topics. Along with that, we will also solve the questions. So when I am revising the concepts, those students who are very good with the concepts, please have patience, because there are some students who might not be able to recall the concepts. So the class is for every student, right? So class is not only for the topper, even for the medium level student, and even for the students who are appearing for the first time, they should understand. So please give me some time. So identify the number of independent sources present in the circuit. This is the first step you must do when you are applying the superposition theorem, and then activate only one independent source at a time and deactivate or remove all other independent sources in the circuit. So please see here, whenever I am writing, I maintained the rhythm very clearly. The rhythm is every time it is independent. Clear? I will also show you what you mean by dependent source, what you have to do when the dependent source is there. So moving ahead, find the response caused by each independent source acting at a time. That is the third step, obviously. And then to get a complete response, add the response caused by individual sources, right? So that means every time activate only one source and get the response. At the end, you accumulate all these responses, then you will get the final answer. Clear? And in case if you have any dependent sources in the circuit, please don't disturb the dependent sources. Clear? Do you know why we should not disturb the dependent source? Any answer from you guys? Why we should not touch the dependent source in the circuit when you are applying the superposition theorem? The problem is, if you disturb the dependent source in the circuit, I repeat, if you disturb the dependent source in the circuit, then the other variables in the circuit will going to change. Clear? Because the other variables may be depending on this source. That is the problem, right? So shall we go to the first question of the day? I want energy from you, right? Raghuram is the only person who has given the answer. I want the energy from each one of you in the comment section. Shall we go to the first question? In 10 minutes I have revised the superposition theorem. Let's go and quickly go through the questions related to superposition theorem. The first question of the day. So every one of you take your pen and paper and be active and solve very fast. We will solve in multiple techniques. Okay. So the first question is, find the current that is flowing through 3 ohm resistance, 3 ohm resistor in the circuit shown below. So where is the 3 ohm resistance? So this is the 3 ohm resistance, and you require to find the current that is flowing through this one. Of course, this question you can solve multiple ways. You can solve by using the nodal analysis. You can solve by using the KVL, KCL, mesh analysis, or else you can use even Thevenin theorem. But let me use the superposition theorem, right? So yes. Yeah. I will tell you, Chandrasekhar. I will tell you the first limitation is it is applicable only for the linear circuit. Clear? Application is wherever you find number of sources, there we will going to apply this. Very simple. Okay. Now, first of all, what I told you, the very first thing I told you, whenever you have this much of complex circuit, try to find out how many independent sources are there. Do you have any dependent source here? All of you answer in the comment section. Do you have any dependent sources here? No, right? So therefore, number of independent sources. First thing is this, number of independent sources equal to 3, right? So 3 independent sources are there. Voltage source and current source. Every time we need to activate only one source and get the response. How do we do that? So for that, let me draw the circuit once again here. So there is a 24 voltage here. Once again, there is a 24 volt voltage. So when you are redrawing the circuit, please be good with the numbers. Otherwise, you will going to get a wrong answer. Okay. So 8 ohm resistance is there here. Of course, here what is there? 4 ohm and 12 ohm, right? So let me take here. All of you please do along with me. And I sincerely appreciate the students who are giving the answer very fast. So 4 ohm resistance is there here. And I know that here 3 ohm resistance is there. And we need to find out the current that is flowing here. What else is there? 4 ohm resistance is there once again, right? So there is a 4 ohm resistance here. And here 3 ampere current source is also there, right? So let me write down 3 ampere current source here. Clear? So well, this is the circuit to you. What I told you first, let us go with only one particular source, that is 12 volt voltage source, right? So that means I can say the total amount of current here is equal to I is equal to the current delivered by the first voltage source, and then the current delivered by the second voltage source plus the current delivered by the third current source. In fact, current source here. Clear? So now the current delivered by the first source, that is voltage source. How do we get that? If you want to keep only this voltage source, then this voltage source should be removed and this current source should be removed. Correct? So therefore, let's keep only 12 volt voltage source and remove the voltage source here. Now I need to remove this 24 volt and 3 ampere here. So as you all know that removing the current source means open circuiting the current source here. Any answer from any one of you? Everyone must answer this. Krishna Murari Singh has given the answer here, but please recheck that one. So open circuit this one, and this might be short circuited here. Voltage source must be short circuited, current source must be open circuited. Now you require to calculate the current delivered by this. I am calling that as the I1 here. Clear? So now tell me, how do we access the I1 value? Can I rewrite this circuit like this? So please see here, when you open circuit this, 4 ohm and 8 ohm both can be connected here, right? So let me say 4 and 8, because if you drop some current here, that current will go like this only. That means 8 ohm and 4 ohm both are connected in series configuration. 8 ohm and 4 ohm both are connected in series configuration, because this is open circuit here. Therefore, the same and similar circuit can be redrawn very conveniently like this. So let me say this is a 4 ohm resistance, and here we have 4 ohm plus 8 ohm resistance. I told you that This and this both are connected in series. How much this will be? So it is equal to 12 ohm resistance. Very nice. So here we have 12 volt. So let's go ahead. This is 12 volt. One second. This is 12 volt here. Well, after that we have 3 ohm resistance here. So this is 3 ohm resistance. Now tell me quickly what is going to be the current here. Guys, I want the answer from every one of you. Wow, wow, wow. Very good. So a lot of students have given 2 ampere. But Nirmal Kumar Gupta is giving 4 ampere. So let me see. So 12 and 4, now these two are in parallel, right? So 12 and 4 both are parallel. How much is the resistance? 12 into 4 plus 12 plus 4, right? So this is 48 by 16. This is going to be 3 ohm here. So simple, right? So therefore, this will be now can be written as 3 ohm equivalent resistance here and 3 ohm resistance here. Of course, then I can say all the way, this is 12 volt here. Now I require the current here. How much this is? This is so simple. I1 is equals to how much? 12 volt divided by 6 ohm. Correct? So easy. 12 volt divided by 6 ohm. So therefore the answer would be equal to 2 ampere here. So easy, right? So now I can say conveniently that the very first current here is going to be 2 ampere, right? So this is the way how we will be finding the response because of one independent source. Now, however, you require to access the second one. How do we go with the second one? So now let me erase this one. So I hope this is clear to you. Let me erase this one because we require the space here itself so that we need not to draw the circuit every time again and again. In case if you find any doubts, please let me know in the comment section. I hope this is clear to every one of you, right? So now let us go to the second voltage source and try to access the current here. Okay. So now second voltage source, how do we get that one? Now bring back, this is open circuit, but now we need to remove this one. So therefore this voltage source, now it must be short circuited here. And what is the voltage source amount here? 24 volt. Guys, you must do along with me very fast. Plus minus here, and this is 24 volt. So how do we get this one? Very good, very good. Payash Kumari, Rajashika, every one of you are answering very well. Now we have 24 volt here. So second case I am doing, right? And this case now we call this as I2. Relax. First relax and try to see how do we get the answer here. Now 3 ohm and 4 ohm, both of these two are parallel. Suppose if I say this is A and this is B here, then this is going to be B, and of course this is going to be B. Correct? Now 3 ohm and 4 ohm both are connected in parallel configuration. If 3 ohm and 4 ohm both are connected in parallel configuration, how do we rewrite the circuit here? So there is no doubt that 8 ohm can be shifted here. So we can shift this 8 ohm just before the voltage source. There is no problem with that. So 24 volt here, and then 4 ohm and 3 ohm both are connected in parallel. So the resultant will be how much? Any one of you? So there is a resultant combination, and then we have 4 ohm resistance again here, right? So let me take, this is a 4 ohm resistance, and this is the equivalent combination of this. This is 4 into 3, 12 divided by 7, right? So this is going to be 12 divided by 7 ohm. That's exactly the overall resistance here. Now guys, can you please tell me? Very good. Raghuram has given the answer 1.75. Every one of you, please let us check with this whether this is correct answer or not. Raghu has given the correct answer or not. Raghu has given the correct answer or not. Now the current supplied by this, if I calculate this I dash, what is the I dash here? So now I dash would be written as equal to the total 24 volt divided by 8 plus 4, that is 12, plus, look at that, 8 plus 4, that is 12, plus 12 by 7. Am I right? So this is 12 by 7. So what it will become now? I dash is equal to 7 into 24 divided by 7 into 24 divided by 7 into 12 plus 12. So it is going to be 8 into 12, right? 8 into 12 here. So what will be the final value here? I dash. Can anybody say what is the I dash value? So this will cancel here 2 times here, and this will cancel here 4 times. So 7 by 4 ampere here. Am I right? So 7 by 4 is correct or not? I dash. The current that is circularly, the current that is flowing here is actually 7 by 4 ampere. So please, very good Hemant, excellent. 7 by 4, right? So 7 by 4, let me make it clearly here. 7 by 4, that is equal to 1.75. 1.75. Neha, very good Neha. So I dash is equal to 1.75 ampere here. Please make sure that I dash is the current that is coming from the 24 voltage source. Guys, please, you require to calculate I2. Don't do mistake here. So this is 1.75 ampere now here, correct? This is 1.75 ampere here. Now when 1.75 ampere comes like this, then it has a parallel resistance here. So easy to understand. So let me make it clear here. Instead of 12/7, now let me rearrange this one again, right? Then you will get a clarity here. So my questions will be little bit difficult because I don't want to solve only the easy questions and bluff here. So because you people are going to write the GATE exam, right? So therefore you must be very good with the big questions and good questions also. Clear? So we know that the current which is coming here is 1.75 ampere here. Clear? 1.75 ampere. Now relax. We require the current that is flowing from this side, A to B. So this might be A for you and this might be B for you. Fine. This is also okay. A to B. Now tell me, A to B means this side current we require. Correct? This side current A to B we require. Right? How do we get that current here? If it is 1.75 ampere current, I'm very sure, just look at it in this way. Don't apply any current here. So assume that this is 1.75 ampere like this. Then out of that 1.75 ampere current, some amount of current will flow here and some amount of current will be flowing here, right? So what is this current that is flowing here? So this current, let me say that is IA. I don't know anything about that. I am asking that as IA. Now 1.75 ampere current is coming here and some part is going through 4 ohm and some part is going to the 3 ohm. So how do we apply the current division rule now? Now we must apply the current division rule. The current that is flowing through the 3 ohm is equals to, obviously the total current is 1.75 into opposite to the 3 ohm is 4 ohm here, 4 ohm divided by 4 plus 3, that is equal to 7. Clear? This is your IA here, right? So I think IA will be equal to 1 ampere, correct? IA will be equal to 1 ampere. But every one of you, is it your value of current that is required? Is it the current what you require? So please look at carefully. Every one of you, please look at carefully, guys. So IA equals to 1 ampere. That is agreeable. I agree with that. But look at what is the current you require. You require the current that is flowing from A to B. Am I right? You require the current. Yes, very good. Excellent. Nirmal Kumar has given the final answer. Great, yaar. So I2. So what is I2 now? I2 is actually the current that is taken from A to B, isn't it? So therefore I2 is equal to minus IA. Therefore it is equal to minus 1 ampere here. Clear? It is going to be considered as minus 1 ampere. I hope you understood. So I2, after this much of elaborated explanation, I can say I2 equals to minus 1 ampere, right? Minus 1 ampere. Now relax. This is clear now. Now just let me go with the third case here. Third case means again I need to erase this one. But my suggestion is, if you have any problem with this, please take the snapshot of this. I hope all of you are agreeing with this answer. So let's go with the third one also and finish fatafat here, because the current source is very important for us. Don't neglect anything. At the end, we need to sum it up the whole currents here, correct? So guys, any answer from you? If anybody completed the whole process, please let me know what is the final answer. Then I appreciate from the bottom of my heart, every one of you. Right. So Ashok is giving minus 1. Excellent, guys. Very nice. I really love your energy and enthusiasm. So just keep momentum and maintain the same thing. You will learn many things in today's session. I promise you. Right. So let's go ahead with the third one. Third one means now this voltage sources must be short circuited here. So let me take the third one here. So when I take the third one, both the voltage sources must be short circuited and this would be considered as I3 here, right? And 3 ampere current is there. Probably I assume that this is the simplest one, 3 ampere current source, correct? Now first, when you want to know what is the current delivered by this, now you can combine these two resistors here. So if I say A and this is still B and this is still B and this is B only. So that means both 3 ohm and 4 ohm are connected in parallel across A and B terminals. Therefore, what should I say here now? So I could say that, so 3 ohm and 4 ohm both are connected in parallel. So it will be equal to 12 divided by 7, same like previous one. And then, so this can be written here as a 4 ohm resistance. And of course, in the upper side, we have like 8 ohm resistance, right? So let me take 8 ohm resistance and then we have still 3 ampere current here, correct? So 3 ampere current, all of you please see carefully here, okay? So then 3 ampere current all the way like this. Now again we must apply current division rule, right? So please apply current division rule and tell me what is the current that is coming here, right? So let us say this is again IA, because we don't know what is that current, right? So IA can be written here as equal to 3 ampere is the total current that is getting divided. So you must look at what is the current that is getting divided. 3 ampere is getting divided, and opposite to this resistance, that is going to be 8 ohm resistor divided by 8 plus 4 plus 12 by 7. So that is 12 plus 12 divided by 7. So how much you will going to get here? Again, this is going to be 24 divided by 24 into 7. 24 into 7. And how much you will going to get? 8 into 12. So 8 into 12. I think the same thing what we got earlier also, right? So it is going to be 2 times here, and this is 4 times here. So you will be having again 7 by 4. What is the value of IA? 7 by 4 means 1.75 ampere if I am not wrong, right? 1.75 ampere. Every one of you, please let me know. Kirtana and Raja, Rajashika, Ashok and Raghuram, Hemant. Is it correct or not? 1.75 ampere is the current that is actually delivered by the 3 ampere in this line. Right? Very good, Hemant. So this is 1.75 ampere. Now this 1.75 ampere, all the way it will come up to here. This is 1.75 only. But this 12 by 7, now we have to split it to know exactly what is happening inside, right? So therefore, let me take this 12 by 7 here and rewrite the resistances. So please see here carefully. So here we do have 3 ohm here now, and this is going to be 4 ohm, right? So guys, fast. So now I3 is the current that is coming here. Now tell me, how do we get this current? So 1.75 is the current that is coming here, and we require this current. But this current is getting divided into this as well as this. That means again we must apply the current division rule once again, correct? So current division rule, how can I say? I3 is equal to the current which is coming here is actually nothing but the total current, that is 1.75 into, what should I say, opposite to 3 ohm resistor where the current is getting divided, that is 4 divided by the total resistance 4 plus 3, that is 7. Now tell me, again you will be having 1 ampere current. Such a beautiful question this is, guys, right? 1 ampere current. So therefore I3 would be again given as 1 ampere current. So totally what is the answer? The final answer for this question, every one of you celebrate it, very happy, good question, right? So I thought that, in fact, I am solving this question, most of the questions I solve directly I solve here, right? Because I want to enjoy the momentum with you. So guys, tell me, all of you are getting 2 amperes, very good. Raghuram is getting 2 ampere. Raghuram is so active, I guess, right? So 2 ampere is the final answer. So Raghu, I think Raghuram, you have attended my control system class, right? Rank up course. Please respond in the comment section. So 2 ampere is the final answer. Final answer is 2 ampere. As I said, option A is the correct answer. Now I will show you the different level of the circuit theory. Satyasri, are you there in the comment section? Satyasri and others. Yes. Very good. Right. Measurements too. Very good, Lokesh. Nice. So 2 ampere current is the current that is finally flowing through this. Just let me ask one question, fatapat here, every one of you. Right. I remember the people, right? I remember. Right. So this is 2 ampere. Excellent. Now I want the power delivered by the 3 ampere current source. Every one of you try to do this. N number of questions we can keep it here. N number of questions, guys. So many questions we can keep. Now it is 2 ampere. That is very easy and noticeable to every one of you. If you want, now you can still go ahead and do multiple calculations here. I am not denying that, because it is going to be 3 ampere. So with this, still we can enhance this question and try to do many things here. Because if you have 2 ampere here, may I know what will be the voltage drop across this one? Every one of you. Now follow me. Every one of you follow me and keep only calculator in your hand and listen and answer to me. Every one of you, see the board here, right? 2 ampere current is flowing in 3 ohm resistor. What is the voltage? 2 ampere is flowing. Very good, lovely guys. So 2 ampere is flowing through 3 ohm, then it is going to be 6 volt. Nice. The voltage across 3 ohm is 6 volt. Well, and this side if I make ground, because usually the lowest point we take it as a ground. If you don't like to take the ground, take some reference voltage here. But I usually take ground here because in lab we will connect it to the ground, right? Neutral voltage. So this is 0 volt, and what will be this voltage then? This is 12 volt straight away. This is 12 volt here, and this is going to be 6 volt here. 6 volt. Then what is the current in this line? Can you tell me fatafat, every one of you? Use calculator fast. Answer to me, right? Answer to me. What is the current here? So the voltage across 4 ohm resistance is 12 minus 6. 6 volt divided by 4. 6 by 4. Every one of you fast. 6 by 4 is how much? 6 divided by 4. 6 divided by 4 is 1.5 ampere here. Good. 1.5 ampere current is flowing here. 1.5 is going here, and here 2 ampere current is there. That means what would be the current that has to come like this through 4 amp? So 2 ampere is coming like this, means 1.5 is going this way. Then definitely this must be 0.5 ampere here. Correct? So 0.5 is coming like this. 1.5 is coming like this. Both get added and then it will become 2 ampere. That 2 ampere current is driven into the 3 ohm resistance. That is how it is going it. Correct? So such a beautiful circuit, right? Every circuit will speak with you. If you love the circuit theory, then a single question is sufficient to know every concept of the circuit theory, right? So now 0.5 ampere. Now can you tell me what would be the current that is coming out of this one? Out of 3 ampere, 0.5 ampere is going this way. Then the remaining is 2.5 ampere here. So 2.5 ampere is flowing here. 2.5 ampere is all the way coming like this. 2.5 ampere here. Clear? 2.5 ampere here, right? Now the first question I asked that power delivered by the current source, right? So if you want to know the power delivered by the current source, first of all you must know what is the voltage across the current source. Correct? You must know what is the voltage across the current source. How do we get the voltage source here? Now the current entering terminal is positive here, so this is plus and this is minus. So 6 volt voltage drop is here, and again what is the voltage drop across this resistor? Now let me take few minutes of time here, so let me erase this one. What is the voltage drop across this one? Voltage drop. This is plus and minus. Guys, 4 ohm into 0.5, that is going to be 2 volt here. Correct? 2 volt drop. Then can you tell me what is the voltage across this one now? Every one of you, fast. 2 volt drop here and 6 volt drop here. So in the loop, to maintain the KVL, obviously it should be plus here and minus here, and 8 volt voltage drop should be pushed here. Correct? 8 volt drop should be pushed. So if it is 8 volt, then only in the loop I can say 8 equals to 2 plus 6. 2 plus 6. Simple. Very simple, right? So then what is the power delivered? Here power is equals to the voltage available across the current source, that is 8 volt, into the current that is delivered by the current source, that is equal to 3. Totally how much it is going to be? 24 volt here. Clear? Sorry, 24 watt here. So I should say this is going to be giving the 24 watt, right? 24 watt power is delivered, right? Power is delivered here. Clear? Good question. How many of you loved it? I think some of the students has given the answer, but they have wrongly given the answer as a 12 watt, but this is actually 24 watt. Question might not be so great question, but we made it so interesting, isn't it? We made it and we together have solved this, so maja aa gaya, right? So so this is 24 watt, right? Now I will ask a question, one more question to every one of you. Okay, so in this independent sources, look at that. In this independent sources, look at what is the other source in the circuit which is delivering the power. Fast. Single questions, many concepts. Navneet, yes. What is the other source that is delivering the voltage? Now this is about current source. Agree? I think you all people can agree with this. That's why whenever I solve the questions of circuit theory or control system, I even don't know what is the time. So time will just pass like that, right? Time will pass like this. See, it is almost half an hour. You are not getting bored. I am not getting bored. Both of you we are energetic. Let's try to learn and explore the concept of engineering together. Okay, let's enjoy together. Now look at that. This is current source. Now let us say 24 volt voltage source. Let's see what is the situation with the 24 volt voltage source. What is the power delivered now? Fatafat, can you tell me? What is the power delivered now? Any one of you? Fast. Yes. Nirmal Kumar Gupta, correct. 24 voltage source kya kar raha hai idhar? So 24 volt and the current delivered by this is very straightforward, that is 2.5, right? So therefore power, this is equal to how much? Let me call this as P1, let me call this as P2. How much that is? 24 volt is the voltage of it, and then you multiply with the 2.5 ampere current. How much it is going to be? Fast. 60. Excellent. Very good. 60 watt. Nice. Wonderful. Now two independent sources khatam ho gaye idhar. What is the third independent source we have? It is 12 volt. Now a simple question to every one of you. Tell me whether this source, that is 12 volt voltage source, is accepting the current or delivering the current. Accepting the current or delivering the current. Every one of you, be fast in the calculation. See now 2.5 ampere is coming like this. This is 2.5 ampere. Out of 2.5 ampere, 1.5 ampere is flowing this side. Out of 2.5 ampere, 1.5 ampere is going this side. How much current will be coming into the voltage source? How much current is into the voltage source? Into the voltage source. So 2.5 minus 1.5. So this is going to be 1 ampere. Correct? Neha, where are you? Neha and Monisha. Monish, yes, very good Neha. Very good pickup. Right? Ravi Shankar, what is your answer? So now 1 ampere current is getting into the voltage source. If the current is entering into the positive terminal of the source, then it means that it is absorbing. If the current is coming out of the positive terminal of the voltage source, means it is delivering. So usually if the current is delivered, then the power is delivered. If the current is taken, then the power is absorbed. Clear? So please try to remember this one, right? So now I could say 12 volt voltage source. 12 volt voltage source. Every one of you, 12 volt voltage source. What is the power? I think many of my friends have already answered that. So let me take P3 here. I think I am only the slowest person here. So 12 volt into 1 ampere, that will be equal to 12 watt. Correct? 12 watt, right? But as it is absorbed, let me write down this as a minus here. Clear? This is minus because it is getting absorbed. Otherwise, you have to say the absorbed power is 12 watt or minus 12 watt. Both are correct. Absorbed power is 12 watt, but P3 is equal to minus 12 watt. Anyway, you can say, right? So now I have one more question here. Can you see about the resistors here? Fatafat, all of you please see what is the situation here. Now, what is the total power that is delivered by the dependent sources? Because we have independent source here 24, 12 and 3. Out of these 3, because they are called sources, correct? So out of these 3 sources, lucky that 2 sources are delivering the power, but 1 source is getting absorbed. Then what is the net power that is balanced here? Net power that is balanced is how much? 24 plus 60. 24 plus 60, that is 84. Out of 84, 12 is already gone. Right? So 12 is already gone. So that means how much is remaining here? 24 plus 60, 84 minus 12. How much it is? 72. Correct? 72 watt is still balanced. Correct? 72 watt is still positive side from all the sources put together. All the sources put together. Let's look at the loads here. Loads means resistors. Fatafat, make the power calculation at 4 ohm resistor now. Power calculation at 4 ohm. That is equal to 1.5 ampere square. Current 1.5 square into 4 ohm resistor. Any one of you, what is the value here? 1.5 square into 4. Right, 1.5 into 4. So 1.5 square into 4. So this will be 9 watt here. So let me say this is 9 watt here. And what about the power? Of course, that is the 3 ohm. So power 3 ohm would be equal to how much? So the current that is flowing here is 2 ampere, I think. So 2 ampere whole square into 3. So that is 4 into 3, 12 watt. Good. And then power across another 4 ohm resistor. This is 4 ohm resistor once again. So once again 4 ohm resistor is there. So what is the current here? 0.5 square, that is I square, 0.5 square into 4 ohm resistor. How much that is? Fast. Every one of you. 0.5 square into 4. 0.5 square into 4. So this will be equal to 1 watt here. So let me write down 1 watt here. And then what else is there? 8 ohm. So P8 ohm, I could say that is, what is the current that is flowing there? 2.5 ampere, right? So 2.5 whole square into 8 here. Any one of you? 2.5 into 8. 2.5 whole square. You have some value into 8 here. So it is 50 watt. Correct? So 50 watt here. Right? 50 watt. Now you must understand all these are actually received powers. That means absorbed powers. Right? So because resistors are going to be dependent elements, so naturally they absorb the power. So power dissipated, power dissipated, power dissipated, power dissipated. So what is the total net power that is dissipated here? So minus 9, minus 12, minus 1, minus 50. How much that will be? Minus 12. So once again, 9 plus 12 plus 1 plus 50 here. So I think it is 72. Minus 72 watt here. Correct? This is minus 72 watt. And this is all across the resistors. Right? All across the resistors. And this minus 72 plus another minus 72. So total absorbed power is how much? Minus 72 watt and another minus 12 watt. So totally it is equal to minus 84 watt here. Correct? Minus 84 watt, because this is also minus, that is also minus, this is minus 84. Now tell me, everyone in the class, every one of you, let me know, what is the total power that is absorbed by all the elements together? What is the total power absorbed by all the elements together? Minus 84 watt. Clear? Minus 84 watt. But what is the total power delivered by the delivered elements? So that is P1 24 watt and 60 watt. Correct? So what is this value? 24 plus 60, that is 80 watt, 84 watt. So therefore I could say the algebraic sum of 84. So now you can see all the way 84 watt is the total power. So let me write down like this here. All of you please see. So I could say in a easy way, that is 24 plus 60. 24 watt plus 60 watt and minus 12 watt here, minus 12 watt. And when I add this all, we got like minus 72, correct? Minus 72 watt. So what is the answer, guys? Any one of you? Can you please tell me what is the final answer here? Final answer. So that is net result is equal to 0, correct? So this has to be matched in every question. If you get like this, then only your solution is correct. Remember this point. Then only your solution is correct. The algebraic sum of all the power calculation in across all elements in a circuit must be equal to 0. If it comes, then only your all calculations are correct, and this is called Telegan's theorem. I think some of the student has mentioned this. This is called Telegan's theorem. I repeat, this is called Telegan's theorem. So Telegan's theorem states that in a linear circuit, the algebraic sum of all the powers will be equal to 0, or else the total power that is delivered equals to the total power that is consumed. Clear? I hope you enjoyed this question. So two theorems I have made it. One is superposition and second one is the Telegan's theorem. Both have done in a single question. How many of you enjoyed this question? We took reasonably half an hour time, right? So reduced current should not be used, no sir, for power calculation across any element or a source. I didn't understood, Kirtana, what you mean to say. Reduced circuit. That's why, yeah, I understood. I got it. I got your point now. Kirtana, yes. That's why I am not reducing the circuit anyway. I am not reducing the circuit. In the given circuit only, I found out what is the current and voltage across the element. Will it be fine? Yes. Kirtana, I agree with you. Right? But in our analysis, we have not reduced the circuit anywhere. Correct? We found the current in a single element. With a single current, we have sketched all the voltages across each and every element and power calculation across each and every element, and then we have proved it, the algebraic sum of all powers equal to 0. Clear? Right. That's exactly, yes. Very good. Right. So how many of you enjoyed this? Oh, I have seen very. See, that's why I'm saying that in a single question, you can learn many things in circuit theory and control system. These are the two subjects. Even in analog electronics also, one question is sufficient to teach the entire syllabus. Okay. Right. Now, thank you, Murali. Let's go to the next question. Right. Don't look at your watch. Okay. Please don't see the time. Just focus on the class. I have the energy. I request you also should have the energy. By the end of this session, we will complete the theorems in a very beautiful way. Okay. So please be with me, right? Yeah, thank you very much, guys. Thanks for your appreciation. Thanks for your love. Find the value of Vx in the circuit shown below. So we require to calculate what is the value of Vx in the circuit shown below. Good. So here we have a dependent source, a 2Vx. There are multiple ways to solve this question. We can use KVL, KCL, mesh analysis, nodal analysis, whatnot, everything we can use. But our intention is to go with the superposition theorem. What we must do, don't disturb the voltage source, dependent voltage source. Don't disturb the dependent voltage source, right? So now the first thing is, we have how many independent sources here? Total number of independent sources. So number of independent sources, I would be saying that is equal to 2. Independent, this is independent sources 2. So what we have to do first we need to keep only one source at a time, but you must understand whatever the voltage you are calculating Vx here, Vx we are calculating here, that Vx must be the summation of both Vx1 and Vx2. That means the Vx created by 10 volt and Vx created by 2 ampere current source. This voltage is created by this voltage is created by this acting alone, and then we need to add these two to get the final answer here. Clear? So Niharika is giving option option A as the correct answer. Let's see, Niharika, whether you are right or wrong, right? So yes. Now let's go one step ahead and redraw the circuit first of all, because if you want to solve, we must redraw the circuit. Other option, no other option. This is the 5 ohm resistance here and minus 2Vx. So let me take here minus and plus 2 times of Vx here, right? So 2 times of Vx, and then it is going to be 10 volt. So let me take here, this is obviously 10 volt voltage source, right? So and then minus 2, this is 2 ohm resistor, and plus here and minus here, this is considered as Vx, okay, right? So now 2 ampere current source is there here. So first of all, let me open circuit the current source here. Okay, if I open circuit the current source, we are getting the response only because of the voltage source. So let me call that as Vx1. Let me call that as Vx1. What is the value of Vx1? Anyone? Sorry sir, didn't see the polarity method. Okay, polarity mentioned. Okay, no problem, Niharika. Now don't do the mistake. Go ahead with this, right? So now in this calculation, we know this is the only voltage source that is independent. So obviously it has to deliver the current here. So let us say there is a current that is coming out of it, and this current has to flow like this only, and this current has to come like this only, and this current has to flow like this only, because it is open circuit, current source is open circuit, and then it will have to circulate like this to reach to the minus 10 volt. If you apply the KVL here now, apply KVL in the loop, right? If you apply KVL in the loop, so just allow me for some time, apply KVL in the loop. So if you apply KVL in the loop, what you will going to get here? Any one of you? Minus 10 first of all, minus 10 plus. So because this current will create plus here and minus here, so this is plus and minus. So 5 times of I here, 5 times of I. Continue here. This is a voltage source, because it is a dependent voltage source, I could say, and its voltage is minus 2 times of Vx, correct? It's a voltage, and we are touching minus plate first, because we are applying the KVL like this side, minus 2Vx, and then continue here. And when you are going ahead like this, right, I am very sure you will going to get minus Vx1 here, correct? Because minus Vx1 directly we can write down. So minus Vx1 equals to 0 here, clear? Equals to 0. Now relax. What is the relation between current and minus Vx1? So can I write like this? Vx1 equals to, because Vx1 is given plus here and minus here, current is entering from the negative terminal, right? Current is entering from the negative terminal. How could I write Vx? Just travel with the Vx1. Vx1 means you are going in this way. Vx1 means you are going from positive to negative, but current is coming in the opposite direction. Therefore, we take this as a minus 2 times of current I here, clear? So I would be written here as minus Vx1 divided by 2 if I am not wrong, clear? I equals to minus Vx1 by 2. Every simple single concept I am explaining in detailed manner. So don't do the mistakes here. It is so simple. Come back here now, minus 10 anyway. So 5 times of, now I is there here. Wherever I is there, just substitute minus Vx1 divided by 2 here. Clear? And then minus 3 times of Vx1 here. On right hand side you are going to have 10. So this is minus 2.5 and minus 3, minus 5.5 times of Vx1, that is equal to 10 volt. So what is Vx1 here? Every one of you please tell me. Vx1 is equal to minus 10 divided by 5.5. How much that will be? All of you please look at that. Minus, yes, 40 by 11. 40 by 11. Yes, 40 by 11. Guys, please look at this properly. This is 5 by 2. I can say 5 by 2 is 2.5. 2.5 and 3, 5.5, right? So please do calculations very accurately, otherwise we will get up with the wrong answer. So it is minus 1.81 I am getting. You people, Ritvik and Syed, please look at Ritvik and Syed. I want answer from you guys. Whether I am correct or wrong, please let me know. 1.82, yes, minus 40. Why a lot of students are giving minus 40 by 11? Minus 40 by 11 is the wrong answer. I feel minus 1.81 is the correct one. Please look at your calculations once again. I want correct answer from your side, right? So minus 1.81 is the value up to here, But look at, yes, plus use nodal, right? Please use nodal. See, Vishwanathan Murali, I can use all the techniques in a single question, but my motive is to discuss the theorem part, right? So I need to show how theorems can be used in a single question. I can use nodal, I can use KVL, KCL, mesh analysis, anything I can use, right? But please, we need to discuss about the theorems part. That's why you need to know how we can apply theorems in each question. Clear? So now this is one side of the story. Now the second side of the story, let me go ahead. Second side of the story, let me redraw the circuit, otherwise it's difficult. So now 10 volt voltage source must be short circuited here. This is the short circuit line here now. And here we do have 5 ohm resistance here. 5 ohm resistance, and then minus second time. This is the second one. And here we have first one. Clear? So minus 2Vx1, 2Vx2 minus plus, and this is 2 times of Vx2. Sorry. Yes. 2 times of Vx2. And now we have a current source. Let me take here 2 ohm, and this is minus and plus, and now this is Vx2, because it is all about the second source we are using here. And what is that current source? Current source value is how much? What is the value of current source? Guys, first 2 ampere, right? So 2 ampere is the current source that is coming here. Now calculate Vx2. How do we do that, right? How do we do that? So 2 ampere is the current source that is there here. And anyway, we must know what is the value of Vx2. Clear? So for this question, obviously we need to apply KVL. There is no other option. Otherwise, in this case, we can apply KCL, right? So let us do a simple calculation here. So let us consider, because if I take this as a ground here, then this will be equal to minus times of Vx2 here. Minus times of Vx2, right? Directly we will get the answer. That's why. So because plus is there here, minus is there. So therefore it is going to be minus Vx2. Source transformation we can apply, but the value of Vx will be inbuilt into the source transform. Then you will going to get confusion. Clear? So let's go ahead with this. So how do we get minus Vx2 here? So the total current that is coming here is 2 ampere here, right? So let me say sum of algebraic current is equal to 0 here. So for that, I could say that one current is IA here and another current is IB here, another current is IC here. So algebraic sum of all the currents equal to 0. So that is KCL. IA plus IB plus IC. I am applying KCL, so that is equal to 0. What is IA? IA is the current that is minus 2 ampere, because you have taken that outside going current. So KCL can be applied in two ways. One is the sum of algebraic sum of all the currents entering at a node should be equal to algebraic sum of currents leaving out of the node. That is one way. Otherwise, take that node as a supreme node and assume that all the currents are leaving out of the node. Then algebraic sum of all the currents must be equal to 0. So second method I am using. So IA is minus 2 ampere. Fine. What is IB here? Any one of you, can you tell me IB value here? IB value we are taking in this way, right? So this voltage minus Vx minus 0, right? So let me take here plus, according to the direction what you have taken, this voltage is minus Vx2 here, minus Vx2 minus 0 divided by 2 ohm resistance, right? So fine. This is 2 ampere. I am let me remove this one. So this is minus 2, right? So 1 second. Yes. Minus 2 here, minus 2 here, right? Because this current IB is this voltage minus this voltage divided by this. But what about IC here? Guys, any one of you, what is IC here? IC is going to be minus Vx2, correct? Because the same can be written like this. So please see clearly here, this 5 ohm can be removed here and I can write down like this. No doubt about this. So please see, minus 2 times of minus plus here and 2 times of Vx2 and 5 ohm here. Clear? 5 ohm. Now, if it is 0 here, ground, then this will be 0 obviously, correct? This will be 0 here. Then this voltage will be how much? 2 times of Vx2 here. 2 times of Vx2, and this is minus Vx2. IC we require. How do we get the IC value here? IC value is going to be plus. This is IB, and IC would be written as plus, going from minus Vx2 to 2Vx2. So therefore minus Vx2, correct, and again minus 2 times of Vx2, 2 times of Vx2 whole divided by 5 ohm here, and that must be equal to 0. This is a simple KCL, right? Right? Simple KCL here, right? Krishna, what happened, Krishna? What happened to you, Krishna? Why you are saying sorry? Any problem? So I think some issue, no problem. So what will going to happen here? Minus 2 and minus Vx2 divided by 2, and then minus 3 Vx2 divided by 5. That is equal to 0. Guys, please tell me what is Vx2 from this now, right? What is Vx2? Yeah, Ravi Shankar, fine. Ravi Shankar, fine. Ravi Shankar, fine. Yeah. After this, yeah. Correct, right. So please tell me what is Vx2, guys. Every one of you. What is Vx2? So here, minus 2, minus 0.5, 3 by 5, let me say. 3 divided by 5, that is 0.6 plus 0.5 here. So it is 1.1. Minus 1.1 Vx2, that is equal to 0. So therefore Vx2 would be, once again it is equal to 2 divided by 1.1, right? 2 divided by 1.1. So it is 2 divided by 1.1. So minus 2 it will come plus side, and this will be minus here. Am I right? Please look at this. Minus 2 by 1.1. 2 divided by 1.1, what is the value, right? It is minus 1.18 again. Minus 1.81. Wow, wonderful question, guys. This is really a good question. Minus 1.81 volt here. Previously, what was our calculation? Same, minus 1.181 volt. So what is the total voltage now? Now the total voltage could be given as equal to minus 1.8 volt, 81 and minus 1.81. So altogether, how much it will going to become? Minus 3.62. What would be the correct answer here? Any one of you from your side? Minus 3.62 volt is the correct answer for this as a Vx. What is the correct answer? Look at the answer and tell me. I think nowhere it was given the proper value, because I think they are giving the magnitude of the voltage, I guess. Okay, magnitude of the voltage. So 40 divided by 3, how much this is? 13 by 3, that is definitely not the correct answer. Have you got the same answer? Answer is not matching. Vx1, Hemant, have you committed mistake anywhere? Everyone is getting same answer, minus 3.61. Hemant Krishna is saying Vx1 galat ho gaya, right? It's fine. If even answer is not matching, no need to worry about that, right? Yes. So V1 is something value. He was saying, Hemant is saying Vx1 calculate karo one more time. Fine, let us see what is the issue with this. Minus 10 and plus 5i. Good. That is again minus 2Vx1. And then when I go like this, either I need to keep 2 into I or else minus Vx1. So this step is absolutely correct. Hemant, you only respond with me. Respond to me. Is this step is correct? When we apply KVL, minus 10 plus 5 times of I and minus 2Vx1 and minus Vx1. Good. Minus Vx1. Absolutely correct this one. So then again here, so the 10 we have taken to this side and minus 3Vx1 is there here, and I value. How we have rewritten here? So I can say here that is 2 times of I equal to minus Vx1. So this is also correct. So I equals to minus Vx1 by 2. This is also correct. Fine. Then we have taken the I value here and substituted here. Then 5 into minus Vx1 by 2. 5 divided by 2, that is 2.5. So this is correct only, right? Minus 5.5 times into Vx1, this is correct. Right? Where it is Raghuram 10, I didn't understood. Hemant, 40 by 11. 40 by 11, what would be the answer? Let me see. 40 by 11. Yes, that's what we are getting. Animesh, right? 40 by 11 only we are getting. Hemant, you please respond to me, because you are the person who was asking that somewhere it is wrong. Is it clear to you? Is this calculation is correct? So please look at this and verify this. If you are wrong, please explain in nodal analysis this. Now clear, very good. See, you don't require to worry about the answers, right? Okay, sometimes it may be problem when the PPT is making or when the PPT is making. Maybe the person who delivered designed this question, There may be wrong answers, they might be provided, right? But we have to be commendable on our approach, right? You and me, both we are solving simultaneously, right? Then there is no, possibility for to do the mistake. So even in case, because here all the calculations are correct, and I have verified with the Hemant also. Hemant, please let me know, confirm in the comment section, is it correct or not? This is minus 1.81 and minus 1.81. Lot of students have used the nodal analysis and given the answer. And given the answer, final answer as, lot of students have given the answer, final answer by using the nodal analysis as minus 40 by 11. Minus 40 by 11, if you see, it will come like minus 3.63 volt only. Clear? Minus 6.3 only. So that means nodal analysis and our approach, finally both are giving the same value, right? So therefore, maybe there is a mistake in the option, right? So they, instead of giving 40 by 11, they might have given 40 by 3, I guess. Clear? That is a typo error. So please don't consider that. Final answer is minus 3.63 volt. Clear? So yes, Hemant Krishna, yes, Navneet, good, very good, right? So now let's get into the next question. Right, Thevenin theorem. So we took almost around 1 hour to explain. Right, sir, explain the current value in nodal analysis, sir, one step, sir. Oh, Ravi Shankar. Okay, so Ravi Shankar is asking me to solve with the nodal analysis. So first let me appreciate him that he came forward and asked. So I can't escape or I can't go away. So let me take one step. And nodal analysis pe maja aa jayega, right? You will be able to get in a single shot answer, right? How do we do in the nodal analysis? Right, so first of all, take this as a node voltage, right? We don't know what is the node voltage, but we know one thing, that this is 0, and this is 0, correct? So let's do in the nodal analysis. Ravi Shankar, please be with me. I am there for you. Satyasri, are you there in the session? Mohit Sen, are you there in the session? Neha, every one of you are there or not? So now if it is 0, then this will be equal to what? This is minus Vx. Raghuram. So minus Vx is here, right? So now relax. So minus Vx I have kept. But what is the voltage here first of all? This is the 10 volt. No doubt about that. That is 10 volt only, right? Now this here, this is a very interesting topic. So please see here. So here, this part we need to write very clearly. Plus and minus. Those students who solve with the nodal analysis, they might face this issue. Assume that this is the 10 volt voltage. And here 5 ohm resistance is there. This is 5 ohm resistance is there. Fine. And then here minus Vx node is there. I just interchanged the resistance here. And then, correct. So here the ground is there. So there is the ground here. And this is 2 ohm resistance. And then another current is coming here. So let me take the current here as a 2 ampere current source. Clear? So this is exactly what is the total analysis of the branch. Now relax. First relax for some time and try to catch up what is the voltage at this point now. What is the voltage at this part, right? Yes sir, I am here only. Very good. So what is the voltage at this part now? The voltage at this part, if you don't know what is that, let us take that as a V dash. Let's take that as a V dash. आपको पता नहीं है क्या है ये voltage. Then take that as a V dash. Then I can say V dash minus 10. So V dash minus 10. So look at that. V dash minus 10. That is equal to 2 times of Vx. ये possible है ना? ये possible है ना? सब लोग को पता है ये. So you know this one, V dash minus 10 is equal to 2 Vx. Perfectly all right. Then V dash is equal to how much? 10 plus 2 times of Vx. This is very well known to you, right? 10 plus 2 Vx. Very nice. 10 plus 2 Vx. Therefore, we know V dash. Now we can blindly apply KVL here. How KCL here? How do we apply KCL? Algebraic sum of all the currents going away from this node, IA, IB, and then IC. Sum of algebraic currents must be equal to 0. IA, this side, IB, and IC. Let me take this as IC. I'm extremely sorry, guys. This is IC. I think I have explained KCL also. So Ashu sir need not to explain KCL once again. I have done a lot of favor to him. Now tell me, if you apply KCL to this, how do we write the KCL here? Let me erase this question, this concept here now. So guys, I think even if I provide the PDF, that may not be valid to you, but you need to keep these concepts in your mind only, right? Now V dash we know that is 10 plus 2Vx. Now if you apply KCL here, algebraic sum of all the currents is equal to 0. IA plus IB plus IC is equal to 0. Relax. Relax for some time. First look at what is IA. IA is the current that you are assuming in this direction. But it was mentioned like 2 ampere in this direction by the current source. Current source is pushing this. So then this will be -2 and plus. What about IB here now? Relax. What is IB? IB is the current that is coming from -Vx to ground. So therefore it would be written as -Vx and -0, that is ground, divided by 2 ohm resistor. That is IB. Fine. And what about IC here? Now IC would be written like this here. So please see, IC is this side current. How do we write that one? How we can write down that one? So it is -Vx and then -V dash -Vx minus V dash divided by 5. Clear? That is equal to 0. Clear? That is equal to 0. Therefore, if you go one step ahead, now I can say confidently, that is, let me take one more step, -2 and here minus 0.5 times of Vx and then this is going to be 1 by 5. 1 by 5 means it is going to be 0.2 times of minus Vx minus V dash is how much? V dash is 10 plus 2Vx, right? 10 plus 2Vx. So 10 minus 2Vx, because minus is there, minus 10 minus 2Vx, all the way this is equal to 0. Clear? Now solve what is Vx here, you will get the final answer. So now clear, Ravi Shankar, for you only I have done this, but while I am doing this, I understood that some of the students may face problem here when they are applying KCL. Satyasri, Neha, Navneet, Ravi Shankar, Hemant, Raghuram, every one of you please respond in the comment section. I want the response from you. Is it clear? This question I have solved even with the KCL, means nodal analysis also, and nodal is such a beautiful topic here, right? So I think now we got a clarity. Just compare whatever the answer you got with the previous answer, that is minus 3.62. Whether you are getting it or not, just verify that, right? Very good, very good, very good. Yes. Nice. Now let's go to the next concept, that is Thevenin theorem. What we will do is, first let me explain the concepts first. So we will do the revision in one shot, and then we will discuss the questions. I think that would be more better way, right? Otherwise we will be, when I am solving the circuit theory questions, I don't find the time also. We will go like that only, right? Okay. So look at what Thevenin theorem states is, it states that a linear two-terminal circuit or a device or an instrument can be replaced by a voltage source VTH in series with a resistor RTH. Okay, that means whatever the linear circuit you have, that can be made as a VTH in series with the resistor. So that means every circuit which is able to deliver the voltage as the output, I repeat, every circuit which is able to deliver the voltage as output, that can be replaced as a voltage source, practical voltage source, and that practical voltage source is the combination of resistance and voltage source, VTH and RTH. And again, as part of your load, again the load will remain same. Clear? Load may be same. Then what is the advantage of this here? So this linear network may consist of 5 independent sources and 10 resistors, 4 inductors, 5 capacitors. But ultimately the whole circuit can be converted into a single voltage source in series with the single impedance. Clear? So when this is happen, now we can change the load, because if this total circuit is converted like VTH in series with the RTH, you can keep any load here, or you can change the load to find out the current delivered to the load. Correct? So that means variable load can be connected, or whenever variable load is there in practical sense, if the load is varying, then the remaining whole circuit will be simply converted into a single voltage source in series with the resistor. So that in future, after 1 or 2 months, even if we keep another load, it will be easy for me to evaluate the entire current that is taken by the load, because the rest of the circuit is same. Clear? I hope I have conveyed the message of this. But where VTH is the open circuit voltage looking into the terminals, RTH is the resistance, equivalent resistance looking into the terminals. Fine. This is called open circuit voltage and open circuit resistance, or Thevenin voltage and Thevenin resistance. Every name is same, right? Now moving ahead, there are specially 3 cases. See, in fact, people do say that there are 3 cases, but I feel that in Thevenin theorem, you require only one basic. That is, suppose, let us say you have a circuit like this. Okay, you have a circuit here, and this circuit has so many voltage sources, current sources, resistors, blah blah blah, many things are there. And if I ask a question to you, what is the resistance between the terminals 1 and 2? How do we find that? So that means even though the circuit is very big, literally speaking it has a lot of elements, but how do we effectively find how much electrical resistance is offered between 1 and 2 terminal? Assume that you are sitting in the laboratory and you are doing this practically. What we will do? Simple way is always take some known voltage source. Let us look at that. Yes, I am connecting a known voltage source of 1 volt. Connect a 1 volt voltage source and look at what is the current taken here. Measure this current. Connect a ammeter here. If you connect the ammeter, you can find what is the value of the current taken. So you can measure this by using the ammeter. And you know this voltage source. Then what is the R12 here? So simple, R12 means the resistance offered between these two terminals, right? So this is R12 here. How much that will be? 1 volt divided by the current shown by the ammeter in the lab, that is IDC. Then you will going to get what is the answer here. That's all, finished, right? So that's it. So every question in circuit theory, especially like Thevenin theorem, Thevenin equivalent circuit, can be solved like this. RTH can be found like this, irrespective of methods. But as usual, people don't satisfy with the basic things. They don't satisfy with the basic thing. They want to make it as a classification. So because sometimes it may be difficult to apply this basic concept, so they come up with some set of rules here. But after following the rules multiple times, then you will understand that the basic concepts are better. Okay, fine. Anyway, so they have divided the like this. Case 1 is if the circuit consists of only independent sources. How do we do that? Case 2 is if the circuit consists of both independent and dependent sources, what we will do. And the case 3 is if the circuit consists of only dependent sources, what we will do. Clear? So, right, Chandrasekhar, correct. So what happens is most of the times I found this, right, even when I was a student, when I prepared for GATE almost 12 years back or 13 years back. So many teachers, they come and say a lot of shortcuts. Everyone used to convince me that GATE is, competitive exam, so you need to remember the formula and you need to mug up the formulas and you need to use the shortcuts. But after solving number of years, a number of questions, what I found is many times it is better to stick to basics. Rarely you should use a very big formula. Whenever you find a big formula, then only you have to go for the formula. Otherwise it is better to believe the basics. The reason is, in a single concept, if you try to remember 4 to 5 variety of formulas, then you will commit the mistake. Rather than go with the basic. That is the easiest way. Clear? But you must be having that art to apply the basics. If you don't have that art, then go with the procedure. Clear? So now let me show you in a single slide. So this slide is very important. So if required, all of you please take the snapshot of this, because this slide is very much useful, especially for the Thevenin theorem. It consists of all 3 cases. Okay. Case number 1, as I said, if the circuit consists of only independent sources, how do we find the VTH? So to find VTH, use any basic technique like KVL, KCL, mesh analysis or nodal analysis. And to find RTH, remove all independent sources from the circuit, right? Short circuit the voltage sources and open circuit the current sources. That is the meaning of removing the independent sources, correct? Yes. So now find the equivalent resistance between the required terminals, that is called as RTH. Anyway, this is the first case, and those students who already know, I appreciate, and those students who don't know anything about that, I again appreciate you, but advise you to stay till the end. I will solve some questions. Okay. So case 2. So case 2 is if the circuit consists of both independent and dependent sources. Both either hai, like independent sources be high and dependent sources be high. In that case, what we have to do? To find VTH, open the load across the load terminal. Of course, this is first step in every case. This is the first step in every case. Even in this case, we must do. Find the open circuit voltage VTH. That means while you are finding VTH, we will again use the same thing. That is whatever the basics we have learnt earlier, we must use the same thing. But while we are finding RTH, there is a difference here. While we are, yes, right, tagline. Thank you very much, Niharika, right? So to find, thank you very much. Yes. Even when I teach in offline, most of the students, they used to make a fun of me like that, right? So every time I say, let's start from the basics. Okay, that is my tagline. Let's start from the basics. Okay, but that is reality also. Open the load across the load terminals. That is fine. Find the short circuit current ISC. Clear? Once you find the short circuit current, in fact, that is a Norton current, then already you know VTH here. And then second time you are finding ISC here. Then VTH by ISC is going to be RTH. Technically, this is always correct. RTH is equal to VTH by ISC. That is all about case 2. Case 3, when it comes, if the circuit has only dependent sources, आपका पास only dependent sources है, कुछ भी नहीं है, right? My doubt is, if we have only dependent sources, who is going to drive that internally? Internally, nobody can drive, right? The circuit cannot be driven internally. If we cannot drive the circuit internally, how the open circuit voltage can be formed? It's not possible, right? If there is no independent sources available inside the circuit, how the open circuit voltage will be formed? That's why VTH will be equal to 0 straight away, right? And even if you calculate the Norton current also will come 0. Clear? So open circuit voltage is equal to 0. But the circuit may offer the resistance if we connect the external voltage source. So that means if the circuit has only dependent sources, it can offer the resistance to external voltage source. That's why it has RTH. Clear? That's why it has RTH. That's why to find the RTH, connect a known voltage source VDC and then find the current drawn by the circuit IDC, then RTH is equal to VDC by IDC. But I say always connect a known voltage source means connect 1 volt voltage source, then calculation will be easy. Now connect a 1 volt voltage source and then RTH will be VDS. So this would be written as now 1 divided by IDC. Simple. IDC is the current taken by the circuit. Very easy. Now I would like to tell you one more thing. Here, instead of doing in this way, we can apply the current source and you can see what is the voltage drawn by the circuit. That is also possible. Reverse also we can do. But one thing you need to apply and calculate the other variable. Then only you can calculate the RTH. So now tell me, is this slide is clear? Every one of you please take the snapshot of this, or else at least after this class I will deliver this PDF in the Telegram group. Hope this is clear. Now let's move on to the first question here. First question on Thevenin theorem, because some of the students may require to know about this. Right. Very good. So this is, look at this statement of the question. First of all, what is the question? Find the current through the load resistance 10 ohm. That means here they might be having the load resistance and the value is 10 ohm. Fine, I do agree with this. Now what I would like to ask here is it case 1 or case 2 or case 3? Case 1, case 2, case 3. Everyone must answer. I would like to see how you are approaching the class. So for that, please respond in the comment section. Don't be neglected. Every one of you, please tell me, is it the first case or second case or third case? This is definitely a first case. So of course, if you want to move forward, then we need to remove that load resistance here, correct? So remove the load resistor, and if you remove the load resistor, what else you will be having here? 4 ohm 32 volt, let me write down here, 4 ohm resistor and 32 volt voltage source we are having, 32 volt voltage source we are having here, and then 12 ohm and 1 ohm resistor is there. So 12 ohm resistance is there here, and of course here 1 ohm resistance, this is 1 ohm resistor, very nice, and then 2 ampere current source behind that, right? So 2 ampere current source. I think this is a good question, decent question. I am expecting this as a good question, right? And we have completely removed the load resistance here. So we removed the load resistance. When you remove the load resistor, rest of all the values are here, and we require to find what is VTH first of all. What is VTH here? So let me take this as a VTH, open circuit voltage across this one, and let me call this as a VA, and let me call this as VB, and all the way I know that I will be connecting this to the ground. If I connect this to the ground, the very first thing what comes to my mind is, let's fix this value as a 32 volt here. Clear? 32 volt voltage, that is going to be there here, right? Excellent. Now this is 12 ampere current. I'm very sure that current cannot go through this line. So if it is 0, then this is going to be VTH directly. So let me say this is VTH here. Why? because VTH could be written as VA minus VB here, but VB is grounded, so 0 volt. So VTH and VA one and all same here. Clear? VTH and VA both are going to be same. Now if it is VTH, then we need to know what is the value of VTH. How we can find that VTH? So to get that VTH, first we need to take this as a V1 here, apply KCL at V1. Every one of you first apply KCL at V1. So IA, IB and IC. IA plus IB plus IC. Otherwise, is there any other way to solve this question? Yes, I think we can go with the source transformation. That would be easy, I think. So source transformation may give the answer so fast compared to this. So let's go with that, right? So first of all, look at that 32 volt and 4 ohm resistors. 32 volt and 4 ohm resistor. Convert this into the source transformation technique. I think Ashu Jangra sir might have revised you about the source transformation technique, right? When you convert this, what you will going to have? 32 volt divided by 4, that is 8 ampere. 32 volt divided by 4 ohm resistor, that is going to be 8 ampere in parallel with the 4 ohm resistance. Therefore, straight away let me remove this one. Any technique you can apply, basic technique, all basic techniques will give the correct answer only. Clear? So therefore, I would be saying here there is a 4 ohm resistor that could be parallel here, first thing 4 ohm, and then 8 ampere current is also there. So 8 ampere current source, right? And 12 and 4 both are connected in parallel here. So what should I say? 4 into 12 divided by 4 plus 12. So that is how much? 3, I guess. 48 by 16, that is 3 ohm. So therefore it is 3 ohm here. So let me go fast here. So this is 3 ohm. I think compared to nodal, we will be able to do here fast. Am I right, guys? 3 ohm. Now convert again this into voltage source. Clear? Convert again this into voltage source. 8 into 3, because when you are converting this current source into voltage source, then voltage value will be equal to current into resistance here. So 8 into 3, obviously I can say 24, correct? So therefore I could say this as a 24 volt here. This is going to be 24 volt here. One second. This is 24 volt. Let me write down. Plus here, minus here, 24 volt here. And here we have 3 ohm resistance. So 3 ohm plus 1 ohm, now it will become 4 ohm. So just give me 1 second time. So then it will become like 3 ohm plus 1 ohm, that is equal to 4 ohm. See, these calculations you should be able to do mentally very fast. Clear? Every time, everything we cannot keep on the paper. You have to be very fast. In 1 month, in 30 days of time, you are about to write the final examination. If I started to say like 3 plus 4 is equal to 7, that's not good at this point of time. You have to be fast, right? So 4 ohm. Now convert again this into current source. How do we convert that into current source? 24 divided by 4, because current is the voltage divided by resistance. So therefore 24 divided by 4 is the 6 ampere current, right? So 6 ampere current. So let me take here 6 ampere current here, 6 ampere current, and this is going to be 4 ohm resistance if I am not wrong, right? So now you can see 6 ampere, 2 ampere both are connected in parallel. Both are pumping the value of the current into a single node. Then what should I say here? So then no doubt that I can remove this one here, 2 ampere, 6 plus 2, totally it will going to be equal to 8 here now, correct? So this is the current source and this is 8 ampere. Now again 8 ampere and 4 ohm resistance, 8 ampere and 4 ohm resistance. What is the voltage source? Again technically this can be converted now, right? So technically this can be converted as, look at that, 8 and 4. So I could say 4 ohm resistance is the value first of all here. This is 4 ohm resistance and 32 volt here. 8 into 4, that is going to be 32 volt here. Clear? That's all. I think we have done a lot of steps here, but every time a single voltage division, I mean like voltage transformation has given the answer very fast, right? So 32 volt. See, it's not a great question, but it's a labor question. So that means we need to work more, right? So what is VTH? Simple. Now, if it is the open circuit value here, so there is no current here, 0 ampere current, no current here because it's an open terminal, no current here. If there is no current, what is the voltage drop across this? 0 ampere into 4 ohm resistor, that is 0 volt. So there is no drop of voltage. If there is no drop of voltage here, if it is 32 volt, then what is VTH finally? Any one of you? Any one of you? What is VTH? VTH is straight away equal to 32 volt because there is no voltage drop across 4 ohm resistance. How many of you got this answer? How many of you got this answer? Satyasri has got the answer. Monisha, Raghuram, Navneet, Rajashika. Very good, guys. Very good. I love your energy And in fact, you are motivating me rather than I am motivating you, because such a wonderful response and flood of responses in the comment section. Love you everyone. I wish best of luck for all of you. So 32 volt is a perfect answer for this, correct. But however, we require to calculate the resistance also. How do we calculate the resistance? First of all, you open circuit this one. If you open circuit this one, right, and remove all the sources. If you remove all sources means this is the short circuited, this will be short circuited, and this will be open circuited. So in that case, I could say clearly that, sorry, let me draw here itself, one second. So here itself. So when I short circuit the voltage source and open circuit the current source, probably you will be having like this 4 ohm here, and this is going to be short circuited here as I said. And of course here we do have like 12 ohm here, 12 ohm, and this is going to be 1 ohm resistance, yes, open circuited, and across the terminals here, right, A and B, this is clear. So please tell me what is RTH now? What is RTH? So here RTH could be written as equal to the open circuit terminal resistance RAB, that is 4 into 12. These two are in parallel configuration along with the series resistance of 1. So 4 into 12 by 4 plus 12 all the way plus 1. What is the value? That is 4 ohm, I think, right? So 4 ohm is the RTH. Excellent, excellent. Very good, Neha. Very good, Malati. Malati, Ashok, Hemant Krishna. Well done, well done. 4 ohm is the correct answer. Now, this question can be rewritten like this. So please see carefully, every one of you. Every one of you, please don't drop it in between. Now 32 volt is the voltage that we are getting here. So let me write down clearly. 32 volt is the voltage, and as I said, 4 ohm resistance, that is a RTH here, 4 ohm, and then bring your load resistance now. So far your load is not connected here, now bring the load here. So when you bring the load here, so the things are simple here. So load resistance is RL here. So what is the load resistance? Load resistance is 10 ohm. Now what is your question? Find the current through the load resistor. So you require to find out what is the current here flowing through this. Let me call that as IL. What is the IL value? Anyone? Quick answer. IL is equal to total voltage in the loop is 32 volt. Single loop, this is 32 volt divided by 4 ohm plus 10 ohm, that is 14 ohm. What is the final answer of the load current here? Any one of you? What is the final answer? I'm not seeing any answer from you. What is the last answer? 2.28. Very good. 32 divided by 14, that is equal to 2.28. Good, good, good. Krishnaveni, good. Krishnaveni, good. So 2.28 ampere is the correct answer. Excellent. Right? I would not say this is a great question. Honestly speaking, this is not a great question, but any question that explains you some concept, it is considered as a great question, because in this question we learn how to apply rigorously the source transformation, correct? But the same question, yes, it's a bit calculative, yes. So in the same question, even without this Thevenin concept, if you have only 10 ohm, directly you can apply without doing this, Thevenin without applying the Thevenin theorem, directly we can solve this question by using the nodal analysis or else mesh analysis, whatever you know. But if I change the load, again you will require to calculate. But if you have VTH and RTH like this, next time instead of 10 ohm, if you keep 100 ohm, then it's very easy because rest of everything is same. That is the main application of the Thevenin theorem. Clear? So because if you follow the fundamental approach, every time when the load is changing, we have to keep on change the calculation. But here it's very easy. That's the beautiful application of Thevenin theorem. I hope I have conveyed the message. Now let's see the second application. Second question. So look at this question now. All of you, please see. In this question, tell me, is it the case 1 or case 2? Again, the load resistance here is going to be 10 ohm. Fine. Tell me, is it the case 1 or case 2? Every one of you. Rohit Pandey. It is going to be case 2. Why? It is case 2 because it has an independent voltage source and a dependent voltage source. Sorry, dependent current source. This is a dependent current source. And the current source, the current is this side, I. Okay. That is I. So we have both independent and dependent source. If both are there, then it is considered as case 2. If case 2 comes, then you must be really careful. So what we have to do first? So let me take this, let me take some time here. First of all, draw the circuit here first. So when you are drawing the circuit, you must be careful, because each and every resistance value you have to write very clearly. Even in the final examination, when you are doing the calculation on the notepad, you must be careful, because what happens is, in the exam they may give 1 ohm, but on the notepad you will write like 10 ohm here and you will do mistake. Okay, so that kind of calculation mistakes are very common in the gate examination. Even I have committed multiple times those mistakes. Okay, that's why I'm saying this. So 2 times of I here, right? So then 1 ohm, and yes, there is 1 ohm resistance here. So what I told you is open circuit here. So load resistance must be open circuited. Yes, I have opened the load. Finished. Now relax. When you open the load, you must be careful here. So what is your aim? Your aim is to find out VTH first of all. Let's calculate VTH here. So VTH is the voltage across this one. How do we find VTH? So let me take this as a B here, and let me take this as A here, and this B, and this is B, and we know this is grounded, and we will be grounding this one, and we'll also connect to the ground. Finished. So VTH could be written as the open circuit voltage, which is actually equal to VA minus VB. But I told you that VB is equal to 0 volt. Therefore VTH itself, it is VA. Now relax and see, it is open circuit line. So there is no current that can flow here. This is 0 ampere. No current can flow there. If no current can flow there, what would be the voltage drop across this 1 ohm resistance? Plus and minus, I should say it is 0 volt. Because when there is no current here, then there is no voltage drop, right? Because current equals to, voltage drop is equal to current flowing through the resistance into resistance. It will be 0 volt. If it is 0, I told you just now VTH and VA one and all same. Please see this line, VTH, VA same. If it is VTH, then bring automatically VTH here. Right, this is VTH. Now conveniently you can apply KCL here. So apply KCL at node VTH now. Apply KCL at node VTH. How do we apply KCL here now? So 3 currents, that is first, here we can say IA, and this must be IB, and this would be IC. Algebraic sum of all the currents must be equal to 0. Therefore I should say IA plus IB plus IC, all the way this is equal to 0. What is IA here? IA, so it is 0 volt here. First of all, this is 0 volt, and I would be saying this as a 10 volt here. So IA could be written as VTH, IA could be written as VTH minus 10, clear, minus 10 divided by 1, correct? So this is 1 current. And what is IB here? IB is coming down, but it is moving in the upward direction. So let me write down that as a minus 2 times of I. Okay, fine. Otherwise then it would be better if I write like this. What you say, guys? So please see here. Right, so I is coming this side, so I can write down IA is equal to minus I, that would be more appropriate I guess, plus IB is going to be 2I, so minus 2 times of I, okay, plus IC equal to 0. IC anyway that is equal to 0, so I need not to worry about that. IC equal to 0. Krishnaveni, VTH is 10, so fine, then I can say IC is 0 anyway, because IC is 0. Therefore, I would be considered as 0 here. I would be considered as 0. That means it is equal to 0. Therefore, I could be written here as 0 ampere here. That means there is no current is flowing here. So this current I, what we have taken here, it is coming like 0. When it is possible, the current here is 0. It means that there is no current that is flowing through this resistance 1 ohm. Means there is no potential drop across 1 ohm resistance. That means VTH must be equal to 10 volt. Then only it's possible. Because if it is 10 volt, this side also 10 volt, 10 volt and 10 volt, equal potential, both the sides, then the current will not flow through the 1 ohm resistance, because the potential drop is 0. Clear? So ultimately, after this much of elaborated explanation, I can conclude that VTH is equal to 0 volt. Such a good question this is, right? Such a good question this. Sorry, VTH sir, did Rakesh Taraja sir left BYJU'S? No. How come Rakesh sir left the BYJU'S? Yeah? No. Swine, no. He handled morning digital electronics session also. Na? Yesterday also regarding marathon session, he only introduced that, right? So He will be coming on the live maybe day after, tomorrow also digital electronics he will be taking the class, and day after tomorrow Rakesh sir and me are handling the control system. Okay. No, Rakesh sir is there. So VTH is equal to 10 volt. Now VTH is fine. That is done. Now we require to find RTH. How do we find RTH? So it's a common sense. When VTH is equal to 10 volt here, we require to find RTH. How do we find RTH? RTH is equal to VTH divided by ISC, that is short circuit current. We require ISC, right? Yeah, Chandrasekhar, correct. So regarding to calculate ISC, what I say is go back to the question once again. So let me take this question here itself. I think what best we can do is, so let me draw here itself, because otherwise now it will take a lot of time to draw the question once again on the other side. So plus and minus here, 10 volt here, right? So this is 2 ampere, sorry, 2 into I all the way, and here we have 1 ohm resistance, and here ISC, short circuit current is there. So short circuit this, and then the short circuit current, let me call this as ISC here, finished, and this is again I here, right? Now how do we approach for ISC here? First of all, ISC here, any one of you, how do we get ISC here? 7.5 ohm, very good. ISC, how do we calculate ISC here? Okay, so first of all, again let's take this as a voltage source here. So this is ISC current, I can say, because this is ISC means obviously this is going to be ISC only, correct? So let us take this as a node which we don't know. Apply KCL at that node. Apply KCL at that node. When you don't have any other technique that is there in your hand, then KCL is the supreme. KCL is the master of job. Okay, every calculation you can do with the KCL. So IA, IB, and some people call this as a nodal analysis also. IA plus IB plus IC equal to 0. IA plus IB plus IC equal to 0. Fatafat, every one of you, tell me, what is IA? IA is equal to V dash minus 10, because this is ground here, and this is going to be 10 here, 10 volt. So IA can be written as a V dash minus 10 divided by 1. Excellent. What about IB? IB is going to be minus 2 times of IA. So let me write down here. So let me write down minus IB. How much that is? Minus 2 times of I. Very nice. And IC. IC can be written as V dash minus 0 plus V dash minus 0 divided by 1. Clear? Minus V dash divided by 0. Yes. Niharika, correct. But we must actually apply this, no? We have not done it. So I value. What is I here? So look at that I. I is a very simple calculation here. I is the current that they have given here, right? I is the current that is flowing from 10 to V dash. So this is always true. 10 minus V dash divided by 1. This is I value. So wherever I is there, now we can replace that. So that is V dash minus 10, first of all here, and then minus 2 times of V dash minus, sorry, 10 minus V dash, 10 minus V dash, right? And again V dash, all the way this is equal to 0. Guys, please solve this equation and tell me what is V dash. Just tell me what is V dash, enough for me. What is V dash? So V dash is how much? 2 times of V dash, and minus of minus, it is going to be plus 4 times of V dash is equal to 30. So 4 times of V dash is equal to 30. So it is going to be 30 by 4, 7.5 volt. Clear? V dash is equal to 7.5 volt. So that means after this much of elaborated calculation, now I can remove all this nonsense here, right? So then if you remove all this nonsense, what is V dash here? So just now only you have confirmed that it is 7.5 volt here, right? So 7.5 volt. Now what is the current that is going here now? Now it's very easy. ISC can be written as 7.5 volt, 7.5 volt minus ground here, that is 0. 7.5 minus 0, 7.5 minus 0 divided by 1 ohm. So how much that is? 7.5 ampere. This is the short circuit current. How many of you got this one? So let me see. Raghuram has got the answer, and some people has already given. Ratan Kumar has given long back, and Niharika is given long back. Okay. So I think you guys are very fast compared to me, because I'm solving and explaining and watching your comments. So it took some time. So ISC is equal to 7.5, because 7.5 volt minus 0 divided by 1, that will come 7.5 ampere. Simple. Very easy, very convenient, no doubt, right? 7.5 ampere. Now tell me clearly, what is your final value of RTH here? VTH already we know, VTH is 10, ITH is 7.5. So finally, what is RTH now? RTH is how much? RTH. Some people are giving the wrong value of RTH. Please look at that. So 10 divided by 7.5, it is going to be 1.33 ampere. 4 by 3, 1.33 is the final answer. 1.33 ohm. This is your RTH. Clear? So likewise, you need to calculate in the second case. This is also a good question. I agree that this is a good question. It's a decent question. Okay. So now I can, it deserves the gate level question. Okay. Let's move on to the third one. That is third case. Third case is specifically when there are no independent sources in the circuit. When there are no independent sources in the circuit, what do we do? Find the Thevenin series, Thevenin equivalent. Basically, this is Thevenin equivalent, right? So again, this might be considered as A and this might be considered as B. Number one. Now, when there are no independent sources, then straight away we can say open circuit voltage across the load or VAB. There are no energizing elements here. So then obviously this is 0 volt. No doubt about this. This is the first conclusion, right? After saying this many times, again, even in the examination, when you see this question, you will get confusion. 10 seconds you will become nervous. That is because of your less confidence. You have to always face the questions very confidently. So VTH is equal to 0. Let's move again and crack this question. How we can move ahead? So let me draw the question here once again. So 2 times of Ix here. So 2 times of Ix. Correct. So and then 3 ohm resistance is there here. So let me take 3 ohm resistance here. Very nice. 3 ohm resistance. And then anyway, I told you that this is A and this is B here. This is B and we require to find out the RTH between A and B. Correct. So what we have to do now? Now we need to apply. They already told that this is the current Ix. They were already saying that the current flowing in 3 ohm is considered as Ix. Good. So let's call or let's apply the known voltage source here. So let's apply the known voltage source, that is DC voltage 1 volt. This is applied. We are applying and let me see what is the current that is coming out here. So let me say the current is I here. If I say this is the current I that is coming out, so how can I write I here now? Very easy question this is, right? So but it's I think previous gate question this is. So 2 times of Ix is the current here because this is the current that is flowing here. 2 times of Ix and this is Ix here. So straightforward, this is very straightforward. I equals to 3 times of Ix. Apply KCL here. So I is coming here, Ix is going like this, 2Ix is going like this. 2Ix plus Ix is equal to 3Ix. I is equal to 3Ix. Clear? So now you require the value of Ix. How do we get Ix? So you applied 1 volt voltage source here. So 1 volt voltage source is parallel across this one, correct? 1 volt is parallel across this one. This is plus and minus here and you applied 1 volt here, right? So when we apply like 1 volt here, how can I write this one now? So can I write like this? The voltage across this current is entering here. So therefore 1 volt could be written as 3 times of Ix here, correct? So therefore Ix is equal to 1 divided by 3 because the voltage across this element is equal to 1 volt, which is equal to current into resistance here. Ix into 3 is equal to 1. So Ix is equal to 1 divided by 3. Simple. So once you know what is the value of Ix here, then bring back and substitute here. Then I will be equal to 3 into 1 by 3. Of course, this is equal to 1 ampere. After a lot of effort, we understood that the current is 1 ampere. Current delivered by the voltage source is 1 ampere. So that means I equals to 1 ampere. Can you tell me what is RTH now? Now RTH is simple. Whatever the voltage you applied divided by whatever the current it is drawing. The whole circuit. This total circuit is drawing a current of how much? 1 ampere into it, right? So therefore I could say 1 volt I applied divided by 1 ampere, the circuit is drawing the current. Therefore the RTH is equal to 1 ohm. This is a good question. I appreciate this question. This is a good question. 1 ohm. So VTH is 0 volt first of all. RTH is equal to 1 ohm. That's the final answer for this question. Guys, you must be with me another 40 minutes. So shall we go ahead and solve maximum power transfer theorem and all other also, just you need to be with me another 40 minutes. Are you be with me? Will you be with me for next 40 minutes so that we can cover the entire theorems? I need answer from you. Every one of you must answer here. Chandrasekhar, Ravishankar, yes, yes. Arun Kumar, Raghuram, wow, wow, wonderful, wonderful, wonderful. Thank you, thank you. Nice. Let's finish the theorems today. Let's finish the theorems so that, yes, yes, please speed up. Ravishankar, okay. I am teacher, no, so I will explain everything slowly. But I know you are almost, see, the students are also like capacitors. I always say, students are like capacitors. What happens when the capacitor is connected to the voltage source through the resistor? Now see, I'll give a simple analogy. This may be useful for you. Resistor, let us say there is a resistor, and here we do have 10 volt voltage source. Assume that, right? And here there is a capacitor. So what is the initial voltage across the capacitor? So maybe you can take this here a transient question. So for example, just 5 minutes, 5 minutes you consider this as a relaxation for you. Again we will increase the speed, right? R and C, right? At t is equal to 0, it is connected, right? Now can you tell me what is the initial voltage on the capacitor generally? Generally initial voltage on the capacitor. No problem, Ravi. I understood, no issue. So initial voltage on the capacitor is always equal to 0, right? Initial voltage is equal to 0 volt, correct? But once you connect the switch, so let's assume that we have connected the switch here, and if you wait for some time, so if you wait for some time, right? Though the resistor is providing the smooth growth of the voltage on the capacitor, though the resistor is providing the smooth growth on the voltage across the capacitor, assume that the resistor is not there. If the resistor is not there, what will happen? The voltage source want to give the total voltage instantaneously to the capacitor load, but the capacitor cannot take the voltage instantaneously. Source want to give everything instantaneously. Load is saying that I can't take everything instantaneously. Then what will happen? Then the switch will blast, correct? Switch will blast, right? So huge amount of heat will be dissipated across the switch, connecting switch. That's why we require the resistor for the smooth growth, correct? So let's assume that I waited for some time, maybe like 10 seconds or some amount of time, or maybe 5 seconds of time, for example. What will going to happen here? Or else maybe you can take 10 seconds only, or 5 seconds, no problem. After 5 seconds, assume that it is equivalent to 10 volt. So the capacitor is slowly charged, and finally it will going to be having the voltage that voltage source has, correct? Initially capacitor doesn't have any voltage, right? But slowly it is accepting the voltage, taking the charge, and finally the voltage across the capacitor will be equal to source voltage. Now you tell me, after some time, when the capacitor reaches to 10 volt, what will going to happen? So it will start acting like a 10 volt voltage source. Then capacitor says to voltage source that I don't require you. Who the hell you are to give the current to me? I already have 10 volt with me, right? Then obviously once it reaches to 10 volt, people say that it is steady state and there is no current here, because this is 10 volt and this is 10 volt. Obviously current cannot go here, right? And then resistor will become useless, correct? Resistor will become useless, right? Now the same situation even with the gate aspirants also, right? So gate aspirants, so initially faculty will be there, faculty fraternity, let me say F stands for faculty, F stands for faculty, faculty के पास इतना knowledge है, right? So and the student is a load here, so let me take the student here, student is like a capacitor as I said, correct? Student. And so for connecting, proper connection, we have BYJU'S here. So let us say BYJU'S is the connecting medium here, BYJU'S is the connecting medium, correct? Initially आपका knowledge 0 है, right? And slowly you will be charged, and finally you will charge such way that the knowledge of the faculty and the student knowledge both will be same, right? Knowledge and faculty and knowledge of the student both will be same. Then that is the point where we call it as a steady state, and our aim is to bring you to the equal level with us. Then what will happen? Then you don't require the help of us, and you will become independent, and you will become the sources, because once you are equipped with the knowledge, then you can deliver the knowledge to the other loads, right? Similarly here, when the capacitor is charged to 10 volt, then this capacitor can be used as a source to deliver the energy to the other elements, correct? That is how the capacitor gets charged, right? So likewise, I appreciate the students who are not having any knowledge at the starting, and they will reach to a state to counter the faculty and to deliver the knowledge to the other students. Anyway, I think I deviated from the point, but I hope you got some good concept here, right? I think you got some good concept. Right, I loved it because circuit theory I love like anything, so everything can be connected to circuit theory. How many of you enjoyed this example? How many of you enjoyed, right? But capacitor will discharge after some time. No, that's why what happens is when the capacitor is discharged after some time, again the capacitor has to be connected to the faculty to charge one more time. So like why? Because when we are when we are using our battery, what happens? After using the battery for some time, the battery gets discharged. Then again we will charge it, right? Right? Correct. But capacitor discharges. Yes, yes. That's why every time you should get charged. Good. So now wonderful that even in this small example also you are arguing with me. That means you reach it to the steady state. Okay, right. So let's go to the maximum power transfer theorem. So here it is given that the statement is simple. Maximum power transfer theorem states that the maximum power will be transferred to the load only when the load resistance is equal to Thevenin resistance as seen from the load. See, first of all, when load resistance, source never run out of the voltage. Good, that's why it is called source, right? So load resistance and RTH all the way, a circuit, a linear two-terminal circuit is connected to the variable load, correct? So if the load is changing continuously, the power received by the load also changes continuously. But the question is, at what value of the load resistor we will going to receive maximum power? That is the question. Simple. So the value of the resistor where we get the maximum power is usually equal to the source resistance or the Thevenin resistance. Clear? This is very simple, and this is valid only when the load resistance is variable. Suppose if RTH is variable, we should not use this. Only when RL is variable, then only we should use this one. Please remember this point. And at that particular value of resistance, the source delivers the maximum power to the load. Clear? Source delivers the maximum power to the load. I hope you understood this. Right? Now let me go ahead and tell you what is the standard procedure to apply the maximum power transfer theorem. First of all, it is almost 90% of the steps is common to your Thevenin theorem. Why? Because if a big circuit is given, first of all you need to find VTH and RTH. And once you find VTH and RTH, then we have to bring RL and connect there. And RL equal to RTH is the condition for the maximum power. Clear? So identify the load terminals, remove the load from the load terminals, and then find the Thevenin voltage across the load terminal, find the Thevenin resistance across the load terminal, then utilize the values of VTH and RTH to calculate the maximum power transfer to the load. Simple. Here, can you tell me what is the maximum power transfer to the load here? So PL equal to the load current square, the current flowing through the load into RL. Simple. And what is the current flowing through the load? So that is also simple. VTH divided by RTH plus RL all the way whole square into RL here. Correct? But I told you that already RTH and RL both are same. If both are same, then what will happen? PL. This is the maximum. PL max. Maximum power that is going through the load or across the load. So how much it will become? VTH square, I would say, divided by 2 times of RL square. So that is 4 times of RL. I think final value is this. So please cross check this and verify this. This is the maximum power. Very good, very good. V square divided by 4 times of RL. That's fantastic. All of you are giving the correct answers. Nice. Now let's move ahead and see what happens in the case of AC circuit, because some of the students, they are asking the question to me, right? I suggest please go through my recorded lectures, especially for AC things, because I know for some students this is the confusion. So go to recorded lectures, or else there is one session on YouTube live. Go to YouTube live where I have explained the MPT, maximum power transfer theorem, derivation of maximum power transfer theorem. In AC circuit, I have derived all conditions. All conditions I have derived, but it is a marathon session, so I need to give only the conclusions, final statements. Let me go with this. Suppose if you are in AC analysis or if you are in AC circuit, so obviously your source is the AC source. AC source must be there to excite the overall circuit. Here we have a source impedance, here we have a load impedance. Source impedance, let me say, or Thevenin impedance ZTH is equal to RTH plus J into XTH. Clear? And similarly, load impedance ZL could be written as RL plus J into XL. So specifically, there are 4 important things I would like to say. Suppose, look at that, if RL is varying and XL is not varying, so only RL is varying. If RL is alone varying, then it will become like, rest of all the things, what it will become now. So now if RL is only varying, then indirectly this XL should come here. So it will become STH plus XL now, correct? STH plus XL. Then the modulus of impedance here will going to become under root of RTH square here, RTH square plus XL plus XTH whole square. Clear? So because we require only the variable component in the load. In the load, if you have only variable resistor, the remaining part you add here. You may argue with me, sir, why we want to add that? So because these two are connected in series, right? So it is so simple to understand. Here we have RTH plus J into XTH, and here we have RL plus J into XL. So we can write down like this. You can add here XTH and XL because RL is a variable thing here. So remove RL here. Now it's very easy for you, right? So then assume that this is the only one variable. So RL is the magnitude of this complex number. That is what you are going to get here. Is it easy or not? Please tell me in the comment section. Now is it clear to you? That's what exactly it was saying. When RL is variable and XL is constant. Clear? RL is variable and XL is constant. Then the load resistance could be written as RTH square plus XL plus XTH whole square. Is it clear or not? Will you forget this one? It is very simple. First write down this as RL plus J into XL. If RL is variable, take the XL to this side and do the calculation. Very, very simple. Clear? Now, suppose RL is fixed, but XL is variable, correct? Then, because this is a complex conjugate here, if it is XL is conjugate, then XL must be equal to minus XTH. And in that case, you cannot use this logic, okay? You cannot use this logic. You have to use the fundamental basics to get the answer. XL must be equal to minus XTH. Suppose RL and XL both are varying, then probably this is very simple. That is RL and XL both are varying. Then in that case, RL would be equal to RTH straight away, but XL must be equal to XTH. Clear? So therefore, it will be equal to RTH minus J XTH. So which is actually considered to be as a complex conjugate of ZTH. Clear? Complex conjugate of ZTH. That's what it was mentioned here. Clear? Suppose if you are having only RL, assume that you have only RL, only load resistance is only there. If you have only one RL here, let us look at in this way. Assume that there is no XL concept here, only load resistance is there. XL, that means what does it mean? It means that XL is 0. It means that XL is equal to 0. You have only RL. Then in this case itself, we can keep XL is equal to 0. If we keep XL is equal to 0, then instead of ZL, we have to write this as a RL, right? So let me write down here, rewrite this one as RL. What is the value of RL? Just solve this and tell me. Under root of RTH square plus STH square, correct? So let me tell you here, RTH square plus STH square here. That's it. RTH square plus STH square. Clear? How many of you understood this and enjoyed this concept? Right? See, if you have only RL, there is no XL, then in this formula you should substitute XL is equal to 0. So simple. Then you will get this one. Clear? So is it clear for AC analysis? All of you please respond in the comment section. Raghuram and Prayash, Lokesh, every one of you. Where we can get this PDF, sir? I will share this, Raghuram. I will share in the Telegram group, or else Shashikant, our admin team will share the PDF in the Telegram group. Okay? So yes, it's clear. So I am taking the confirmation from you. I'll solve the questions after few minutes of time, because I will solve definitely. Otherwise also no problem. In YouTube live already I have solved many questions in YouTube live on theorems. You can go through that. But let me explain first this reciprocity theorem and others. Let me wind up this first, because otherwise some students may leave without going through the concept. Okay? Telegram link, sir. Okay? Telegram link, those students who are coming for the very first time to my classes. So you can type IN Guru 22. Okay, so directly you will be directed to, you will be directed to Telegram group. There you can go ahead. Or else if anyone has my Telegram link, please share in the group so that the other students will get benefit out of it. So reciprocity theorem, I love reciprocity theorem. In fact, so out of all theorems, this is the theorem which I like most because it is always challenging. Reciprocity theorem states that in a linear bilateral network, please keep this in the mind, linear bilateral network, the ratio between the responses to the excitation remains the same even after the position of the response and excitation are changed, interchanged. One second. Are interchanged here. Position of the response and excitation are interchanged. Thank you very much, Raghuram. Thank you very much. Once again, I am saying that the questions on maximum power transfer theorem was very well discussed in the YouTube live session only. You can watch that, Gate Aimer series, there you can find. Okay. First, let me complete the reciprocity theorem here. So what it says is, we have a linear bilateral network here. So when we apply the excitation here, we got the response here. Second time when I switch the, when I interchange the excitation and response, the ratio of the response to excitation remains the same if this is a linear bilateral network. Ratio of the response to excitation. So let me say, first of all, I applied, X1 and I got here Y1. Clear? Second time, when I switch to this side, right? So X1, Y2. Second time when I apply excitation from the second port, I get the response in the first port, that is Y1. So in the first case, what is the response to excitation ratio? So Y2 divided by X1, that means the output coming in the second port divided by the excitation given in the first port, that must be equal to here. What is the response? The response is coming in the first port here divided by the excitation given in the second port. This is actually considered as a reciprocity theorem. X1 means the energy given or the excitation given in the first port. Y2 means the response obtained in the second port. Clear? Second port. I hope you understood this. Vi is constant. Excellent. Perfect. Right? Now I will give you a simple application because many students may ask that what is the application. Simple. Just take a linear bilateral network here. Suppose if you apply 2 volt from here, this is the port 1 and there is a bulb here. So you can see bulb here. So how much current is flowing through the bulb? 2 ampere. Now take this 2 volt to here and take the bulb to this side. Then if you have 2 volt here, then probably the bulb might be having 2 ampere current. But you have enhanced the voltage 2 times. What is the current here now? Can you tell me? So here when we have 2 volt, you got 2 ampere here. That means instead of 4 volt, really if I have 2 volt only, then probably I could write directly this as a 2 ampere current. No doubt about this. No doubt about this. But now we don't have 2 volt, we have 4 volt. So 4 volt could be written as 2 times of 2 volt. That means it is a linear network. If it is a linear network, when you enhance the voltage by 2 times, 2 volt into 2 will become 4 volt. Then this response also must be multiplied by 2. Correct? So 2 into 2, that will become 4. So therefore, finally the current here could be written as a 4 ampere. And do you require a great mathematics physics for this question? It's a common sense, right? It's really very common sense. Correct or not? So that means when you change the position of the source, then obviously because of the linearity, when we multiply here, the same constant should be multiplied here. And that's why I say that this will be useful. In fact, you can apply the reciprocity theorem only for the linear networks. Please remember this point. Okay. So moving ahead. So there are some particular limitations with this. Please keep this in the mind. The circuit having time varying element, then the reciprocity theorem cannot be applicable. This is very, very important. If the circuit has a time varying element, you cannot apply the reciprocity theorem. Please keep this point in your mind. They may trap you in the exam. Second is the circuit having the dependent sources even, it is linear, then the reciprocity theorem cannot be applicable. So please keep these points in your mind. Third one is the circuit having a non-linear element like diode, then also we cannot apply this theorem. So because now we have multiple choice questions also, right? They may ask a question like, in which of the following situations the reciprocity theorem cannot be applied? Or else they may ask that in which of the cases the reciprocity theorem can be applied. Both are correct, right? So that's why MSQ is very important. All these points should be noted down by you. Now let me take one simple question. I'm interested in solving this question because it's one of the fantastic question. Let me see how many of you will give the answer to me. Okay, Raghuram, Hemant and Krishnaveni and Satyasri, Lokesh, Navneet and Neha, please let me know what is the answer for this question. Raghuram is giving very fast answer. Find the value of current I in the circuit. Now don't go for your like calculations, just use the common sense, because common sense is very powerful. Niharika, what is the current I value? Niharika, Krishnaveni, both of you please tell me. Suppose, look at that. Let me consider this side as a port 1 and this side as a port 2. Clear? This side as a port 2. So port 1 and port 2 are there. Fine, I agree. If we have 20 volt here, we will be getting 4 ampere here. If we have 20 volt here, we will be getting 4 ampere here. Excellent. Now what we do is, here let me interchange the position of 20 volt here. Assume that 60 volt is not there. 60 volt is not there. Assume that 60 volt is not there. Or else, first of all, you tell me here itself. This is good, I guess. Let us take the same network here. Same network. Same network. Instead of 20 volt, right? So let me take here 3 times multiply here. So when you multiply 3 times, how much you will going to have? 3 into 2, 60 volt you will be having, correct? 60. If you multiply 3 times, it's a linear network. Everywhere it will become 3 times, right? 3 times into 10 and it will become 3 times here also, correct? Because it's a linear network. So 3 times into 10 means it will be obviously 30 amperes now, correct? So that means if you have 60 volt here, it will become 30 amperes here. No doubt about that. So anyway, here you will be having 12 amperes for us. 12 ampere current. Let me make it this so simple here. And anyway, this is the parental network here. So let me go back to the original network, right? Original network is this. So from the original network, we used our basics so strong and we got this one. So happy about it, right? Now look at this. This is what we require here. So what I do is just take the same circuit again here. Apply the reciprocity theorem. Apply the reciprocity theorem means what we can say here. Now let's take the network here. First of all, this is a network. This is a network, if I am not wrong. And if I interchange the position of the source, here, that is plus 20 here. When we interchange the source like this, other side the response would be how much? So the ratio of response to excitation must be same. So that means it must be 4 ampere only here. Will you agree with this one? That means from this I applied the reciprocity theorem. From here to here it is a linearity. Simple scaling operation. And here to here it is a reciprocity theorem. Reciprocity theorem, let me write down RPT. Clear? Now what I do is, again let me apply the linearity over this. Linearity over this means just multiply 3 times. When you multiply 3 times here, then how much it will going to become now? It will become 3 times here. Now 3 times I need to multiply here. So therefore if it is 60 volt there, once again 60 volt here, let me say this is going to be 60 volt. I could say this is 60 volt. And what is this current now? So 4 into 3, obviously this is equal to 12 ampere. Simple, very simple question. 12 ampere. So let me write down this is a 12 ampere. Clear? 4 into 2, 12 ampere. Now we have applied a reciprocity plus linearity both. Then we got this one, correct? Reciprocity plus linearity. Now our intention is we need to find out the current when we have 60 volt in port 1 as well as port 2 both. We have 60 volt here, we have 60 volt here. We must know what is this current I. So what we should say, here we have 60 volt here, we do have 60 volt here. Now again, so linearity means 2 principles are there. One is a scaling factor, second one is a additivity. The principle of additivity, the principle of homogeneity, both are together considered as a superposition theorem. So what we must do now? Now we must add both of these two. If we add these two, right, so what should I say? This is 12 ampere means it will going to be 12 ampere only. So if we add these two, what will going to happen? If you sum up these two, then again I would be saying that this is a network. Absolutely this is a network. No doubt, I don't have any second thought here. This is a network for sure. If it is network here, so now look at that. So 60 volt is there. First of all, this side also 60 volt is there. Now when we add both of these two, one side it is 60 volt here, and here also we will be having 60 volt if I am not wrong. So this side also you will be having 60 volt here, correct? 60 volt, 60 volt, relax. 60 volt, 60 volt. Now the current which is there this side 30 ampere, and this side it is coming like 12. So both are negative. So in fact it is like 30 is coming this side 30 ampere and 12 ampere is coming this side, correct? So that means when we add both of these two, effectively how much it will become now? Effectively 30 is dominating, 30 minus 12. So net current would be equal to 18 amperes. Correct? Net current is equal to 18 amperes. But this side, what is the situation? So that side is not required because our question is only to find current I here. Correct? So let us go with that. So because if you see your question, 60 volt is there here. Yes, 60 volt is there. 60 volt is there. And you require the current that is coming this side. But actually the current is going in this way. So you require current in this way. So what is the I value now? I value is equal to minus 18 ampere. How many of you enjoyed this question? Please let me know in the comment section. I want the response from you. The doka gaya, right? Now cleared, sir. Very good, very good. Raghuram, so then you have to thank me, right? So I at least require one beautiful appreciation from you, right? So because this is a common question, as I know, most of the students after I complete my class, lot of students they come to me and ask this question multiple times. Sir, nahi samajh aaya sir. Once again repeat. The reason is you miss your common sense and go on the formula. That is where you do the mistake. Go with the common sense. Superposition theorem means it's a combination of both the scaling property and addition property, correct? Scaling and addition both mixed together, it is called superposition. So you need to know to scale that properly, and at the end we need to add that properly. How many of you enjoyed this question? Please let me know. Ravi Shankar, Raghuram, Malati and Monisha and Hemant Kumar, Ratan Kumar. This is one of the good question. There are like this lot of questions are there. So I once again suggest if anybody want to solve more number of questions, especially on reciprocity theorem, just to go to the recorded lectures and find the title like questions on reciprocity theorem alone. So then you will be finding at least 4 to 5 questions. Okay, very good question, quality questions. 4 to 5, not like dumb questions. They are very, very quality questions. Directly you can find this lecture in recorded lecture in the app itself. Go through that. Then you will find a lot of good questions. Well, let me come to the last theorem of the discussion. That is, see, Milliman's theorem. I should say that only for the time sake and only the purpose I am just discussing. But you can solve every question. Wherever we require Milliman's theorem, we don't require to apply the Milliman's theorem. Even with the simple source transformation technique, we can solve the question. That means in practical sense, as far as the GATE exam is considered, in competitive environment, you don't require really to apply Milliman's theorem. Even if you apply source transformation technique, you will get the answer. Clear? So that's why. But statement should be known to you. So if n voltage sources V1, V2, V3 up to Vn of internal resistances R1, R2, R3 are connected in parallel, then these voltage sources can be replaced by a single voltage source V in series with the resistance R. So see here, we have a voltage source and resistor. Now in practical sense, you can convert this into a current source, convert this into a current source, and likewise you can do a lot of things here, correct? So but if you convert everything into a single voltage source and in series with the resistor, then the voltage source could be written as equal to, please try to keep this in mind, V1 G1 plus V2 G2 so on to Vn and Gn. Vn and Gn divided by I would be saying that G1 plus G2 plus G3, of course, so on to Gn. Clear? So that is the final voltage. And if anybody again, if you want the formula for that, go through the recorded lectures. Otherwise it will see whenever it is getting buffered, please refresh it. Please refresh it. So if you want the formula of proof of this, please go through the conceptual classes or the recorded lectures. Right. Now if you want the R, that means the equivalent resistance R here, whatever you want here. How do we find R? R would be a very simple thing here. R could be written as a G1 plus, in fact, yeah, G2 plus G3. So in fact, I would be saying that R is very easy concept here. So instead of writing this, I can even say like this also. So 1 by R equal to, because it is a parallel combination of all these resistors only, once you convert that, right? So therefore it could be written like 1 by R1 plus 1 by R2 so on to Rn here. Clear? 1 by Rn here, right? Or else G can be written as G equal to, so it would be written as Z1 plus G2. And the best thing is this only. I think this would be easy to remember this, because it's a parallel combination of all resistors. When you convert this each and every branch to current source, then all these resistors comes in parallel. Therefore, the parallel combination could be written like this: 1 by R is equal to all the way this one. And here G1, G2, G3, all these things are what? So G1 is equal to 1 by R1 and G2 is equal to 1 by R2 likewise. I hope I have conveyed the message. It is very simple. In fact, you don't require to know all these things to solve any question. I will prove that in a single question. So let me take, of course, these are the limitations of Milliman's theorem and applications of Milliman's theorem, because if anybody is interested to write the ESC examination, sometimes in the prelims examination you will be asked, asking about the questions related to limitations and applications. So please keep this data with you. Let me directly go to the question here. So suppose find the current through the load resistance RL. So you require to find what is IL here. So in this case, technically people say that you apply Milliman's theorem, but I say that you apply your common sense, okay, basics, that you don't really go to the Milliman's theorem. How we can solve this one? 5 volt 5 amp. So convert that into current source. So then it will going to be equal to what? So please see here. So here current source, first of all 5 divided by 5, 1 ampere current source here, and here we will be having a resistor here, that is 5 ohm here. Clear? And then again one more current source we are having here, right? So 7 by 10, so 7 volt by 10, so it is a 0.7 ampere here, and again a resistor is there here. Clear? So a resistor, that is 10 ohm here, correct? And then again we have one more voltage source that can be converted to current source. So what is the value here? 9 by 15. 9 by 15 means how much? 9 by 15, guys, fast. 9 divided by 15, how much that is? 3 by 5, 0.6 ampere. 0.6 ampere. Of course, we do have again the resistance of 15 ohm that comes here. So that is 15 ohm. And then naturally we have load resistor here, which is of 3 ohm here. So let me write down 3 ohm. And we require to find the current flowing through the load. Tell me, any one of you. Navneet has given the answer very fast here. 0.6 Navneet has given, so let me make it clearly. 1 plus 0.7 plus 0.6. How much this all put together? 1 plus 0.6 plus 0.7. So 1.3 plus 1. 2.3 ampere is the current here. So let me write 2.3 here. And then 5 and 10 and 15. All three are connected in parallel configuration. So 1 by R is the equivalent resistance, that is equal to 1 by 5 plus 1 by 10 plus 1 by 15. Correct? So can anybody make it for me and tell me what is the equivalent resistance here now? Right? 1 by 15. So let me write down 1 divided by 5, that is 0.2 plus 0.1, yes, plus 1 divided by 15, yes, you have a lot of value, 0.366, and we need to take the inverse of this, right? So it is 2.72. The resistance is 2.72, I think. Resistance is 2.72 if I am not wrong. Let me take this value. Resistance is 2.72 ohm. Resistance is 2.72 ohm here. Clear? Simple. So therefore, now we will be simply having like 2.72 ohm resistance here, and here we have a load resistance of 3 ohm. Load resistance of 3 ohm. So let us say the current we require to find here. How do we calculate the current here? So simple. Now we can apply current division rule, isn't it? So let me go with the current division rule here once again. If I go with the current division rule, what you will going to get? IL, that is the load current, equals to, so this is 2.3 ampere current. So 2.3 ampere current will come up to here first of all. So 2.3 is the total current into opposite resistance to 3 ohm is 2.72 divided by 2.72 plus 3, that is 5.72. Clear? So what is the total current now? Any one of you, load current is how much? I need to know answer from you guys. 2.3 into 2.3 is the overall current. Yes, into 2.72 divided by 5.72. 1.093 is the answer. 1.09 ampere is the final answer here. How many of you got this one? So please let me know in the comment section, guys. 1.09 I am getting. Please verify and tell me whether I am correct or not here. 1.09 Manoshi, yeah. Monisha 1.093. Correct, Neha. Well done. Well done. 1.093 is the correct answer. Now you tell me in this question, technically speaking, we haven't applied any of the Milliman's theorem, formula, but still we got the answer. That's what I am saying. Milliman's theorem you require to know just only for the sake purpose. That means only for what you say, yes, you have studied this. But in reality, we can apply the basics, whatever you have studied earlier, and you will get the answer very fast. I would say, if you know the formula and if you can apply the formula so easily, you can apply. I never deny anyone that don't go for more formulas. I only say that go for the formulas whichever is required to remember. Otherwise, simply don't try to number of formulas and mug up those things, because if you try to learn more and more of formulas on a single concept, then in the exam you will not be able to recall all the things. That's why majority times you should go with the basics. Whenever you feel that it is difficult to get that formula in the exam, that you should work out more problems on that. Clear? So I hope I have conveyed all the concepts very clearly. So the last question of the day, can you please read this and tell me the answer? I am waiting for your answer. The theorem which states that in any linear, non-linear, passive, active, time variant and time invariant network, such a beautiful network this is, right? Any linear, non-linear, passive, active, time variant and time invariant network, the summation of instantaneous power is equal to 0, will be called as dash. So option A, I think I have discussed about the statement of the Telegon's theorem in the very first theorem itself. While I was doing the superposition theorem, there itself I have delivered it. Clear? So hope I have completed this, right? All the concepts whatever I require to complete, I have made it very clearly. But however, I would suggest for the students, suppose there are some students who might be writing in 2024 examination, or there might be some students who want to solve more number of questions, right? One stop solution is just download BEP app and you can find my recorded lectures there. And in recorded lectures, you need not to go through the concepts now, you can directly go through the questions, because in recorded lectures you will find the separate lectures for the concepts and separate lectures for the questions, like the concept related to maximum power transfer theorem and questions related to maximum power transfer theorem. So just go to questions related to maximum power transfer theorem and solve all the questions. No need to solve, just listen, then you will be able to know everything. Clear? Right? So I hope I have done the session here, and this is the test series. And as you know, on BYJU'S exam prep platform, we do have both subject wise test series as well as full mock test series and even open mega mocks also. Okay, if you want to really taste the challenge, open competition, then BYJU'S exam prep is a one-stop solution for you. And of course, these are some of the very, very important products. If anyone is aiming for 2024, you can go through all the things. Okay, so guys, I think we have made it. I have covered all the session, all the theorems in 2.5 hours session, and it's really a great motivation from you. And I have seen fantastic energy. Sitting for 9 hours, really it is not a joke, right? So even teaching 9 hours is easy compared to sitting 9 hours in front of the screen and listening to someone. I really appreciate for all your effort, and I sincerely wish best wishes to every one of you. I pray to the God that you will definitely get a good success in your final examination. Till the end, never get demotivated. Stay confident, stay motivated, stay connected to BYJU'S exam prep channel. So we will be meeting once again for control system section, I think a day after tomorrow or maybe after that day, and I will be handling the part of frequency response plot, as many of the students are requesting me. Means I am going to take both Bode plot and Nyquist plot, polar plot, gain margin and phase margin and state space analysis of the control system part, either day after tomorrow or else one day after that. I will be coming again on live for the marathon session, specially to discuss control system questions. Till then, yes, Navneet, tomorrow you have both second part of digital electronics and second part of circuit theory also. Same schedule, 10 a.m. to 2 p.m. you will be having digital electronics tomorrow morning, and afternoon session means from 4 p.m. to 8 p.m. evening session you will be having circuit theory part 2. Clear? Thank you very much Janani, and thank you very much Malati and Raghuram. Once again, thank you very much to each and every one of you, and I wish all the best till the end. Stay connected with us. Clear? So well, thank you guys.